You can spotlight me now. Okay, I'm gonna share my screen. Give me a second. Okay. Let's see, we have a few participants. I'm going to start on time. Good morning, everyone, or good evening, good afternoon, wherever you are, or very early morning to those on the West Coast. So today is the last day of the BioCreative Challenge Evaluation Workshop. Thank you for being here. Just first, a few general guidelines so we can get the thing started smoothly. First of all, we ask that attendees and panelists make sure that you're muted during the workshop, especially panelists. In the discussion session, we probably will allow the attendees to raise their hands so we can and talk if you want, but at that point, you also have to make sure that you are muted. In terms of any questions, usually these sessions, for those who are coming for the first time, this session, we run the talks, and after we have some question and answer session, and this is through the Q&A box. So if you have a question, put it there and we will take care. However, panelists who are the speakers who are behind the scenes, they have to use the chat box. So please make sure you put your question so everyone can see it. So because you can select whether you want to share it with everyone or with the panelists only. And you can use the chat box for any other communications. This is for everyone. First of all, we expect a very respectful behavior for everyone here, and that has been happening, so thank you. And if you have any issue, either technical or any other, just email us or add the information in the chat box selecting any of the organizers. So again, for those you know already, if you've been here, but if you are new, just the proceedings are available through the BioCreative website or just scanning this QR code. And also do not forget to visit the posters. These are short videos which are in a YouTube channel. And you can tweet anything about this workshop, use the hashtag BioCreative. Today is the last day, so the program has very interesting sessions. These are COVID-19 centric. In the morning will be about the shared task on the lead COVID multi-level topic classification for COVID-19 literature annotation, which will be chaired by Resarta Islamah from NLM NIH. And the second session will be about the interactive demo on COVID-19 text mining tools that will be chaired by Lynette Hirschman from MITRE. And after that, we really hope that you can stay for some discussion. It will be important for us to get your feedback on what are the next directions for BioCreative in many different aspects, and also not only directions of BioCreative, by understanding the needs and the difficulties from developers or users. Just a reminder who has been involved in making BioCreative possible for this time. It's a nice group and very talented group of collaborators, and also another talented group who helped to make this possible. Julie Coward and Emily Alden from University of Delaware for helping with proceedings and BioCreative website. Christopher Martin from Media Services at UD is helping with all these technical assistance on the sub-webinar. Antonio Miranda Escalada from Barcelona Supercomputer Center for setting up the YouTube channel, and the International Society for Biocuration for being such great supporter of the BioCreative in general, because there's always users coming from that community you'll see soon. that are really very eager to try the things that we present to them. And in general, to all participants, users, and who took the time from their busy schedule to be here or to do some task related to this. Thank you. So now I'm passing to, let me stop sharing. I'm going to pass to Resalta, who will be the first chair of the session in the morning. Thank you.
Thank you, Cecilia. Hello and welcome to track 5 of BioCreative 7. This is really exciting. This is the third day of BioCreative 7, and we've had a good community so far. The first 2 days, we heard from the NLM CAM, we heard from the Twitter dataset, we heard from DrugProt. We had a fantastic panel yesterday on adverse drug reactions. Today, we have the first track that we're going to talk about, and we're going to meet right now, is the lead COVID track, the multi-level topic classification for COVID-19 literature annotation. This track and this topic is actually new in the history of BioCreative. It's the first of this kind, and it's very timely because it addresses a need that rose recently during COVID-19 pandemic. The lead COVID collection of papers in PubMed contains more than 100,000 articles, and it is desirable to have these articles classified in 8 possible topics. But I will ask for Jinyu Sheng, who was the leader of this track, to give us an overview and tell us how many teams participated and what were the results.
Thank you, Rosetta. So let me share my screen. Okay, hello everyone. I'm Qingyu Chen, a research fellow from the National Library of Medicine, National Institutes of Health. So thanks for Cecilia and Rosetta's introduction. So today's track is all about COVID-19. So I'm specifically talking about track 5, the lead COVID track for multi-label topic classification for COVID-19 literature annotation. So while this is a virtual workshop, so all the organizers have been giving the best smiling to all the BioCreative audience. So just keep in mind, I have an evil smile, but I have been trying my level best. Anyway, so let me start with the general background. So we all know COVID-19 literature has been growing rapidly, but how exactly? So we have been measured the growth rate, and here are some numbers for you. So about each month since May last year, it has been about 10,000 articles. For every month, there are 10,000 COVID-19 articles added to PubMed. And the peak time was like over 2,500 articles just in added in a single day. And it has been accounting for about 7 to 8% of the entire PubMed collections. So such rapid growth of COVID-19 literature challenges like the traditional search and curation, and not to mention there are some language variations. So this is a slide about all the COVID-19 related terms that's been used in the literature. So for example, before they have official names, they have been used. So they already have a range of the terms have been described the same coronavirus. And even after the COVID-19 officially introduced, there's still many more variety of the terms have been described this coronavirus. So the rapid growth and also language variations significantly challenge the COVID-19 literature search. That's the motivation that we developed Lead COVID. We want to have one-stop literature hub that triage and curate COVID-19 literature from PubMed. It has been updated daily since February last year. It has over 35 million of hits and has been used for a range of use cases. It has also been used for institutes or government or health organizations. So the topic today, we talked about curation in LeetCovid. There are essentially three main components of the LeetCovid curation pipeline that we are doing every day. So the first one is document triage. It's for identifying COVID-19 related articles from everyday, the new articles from PubMed. Also, the second one is anti-extraction. It tries to extract locations, chemicals, and recently we have deployed mutations and vaccines that have been mentioned in literature. The third one is our focus today, is for topic annotation. It's to categorize articles into broad topics. So for example, like treatment, or recently we have long COVID. So the first question is why we need annotate topics, why it's useful. So the aim of the topic annotation is to quickly discover some broad topics from the COVID-19 collection. We have been measuring the use case, the use accesses of LeetCovid. So we find actually for topic-related browsing behaviors is accounting for about 20% of total uses in LeetCovid. Not only it has been a popular usage in the LeetCovid itself, the annotated topics have also been broadly used in downstream studies, for example, for evidence attribution via the curation, for example, for literature influence analysis. There's also some downstream literature portals that have been used the annotated topics. They have been used for knowledge network generation. Some of the downstream studies also interested in like more fine-grained or subtopic analysis. So here's the overview of characteristics of the annotated topics in LeetCovid. So figure A shows the occurrences of each topic. So for example, prevention and treatment, they account to the two main annotated topics. The figure B shows the co-occurrences of those topics. For example, there are some topics that have been co-occurred frequently, like mechanism and treatment. For example, one article might talk about the underlying biological mechanism and how its implications to the drug development. For example, they have transmission. For example, it may talk about the mode of the transmission and how to prevent such transmission. And the figure C shows like about 30% of articles, they have more than one topics annotated. So initially, we have an initial set of 7 topics that was selected. That time were about 300 to 500 articles in total in LeetCovid. We did some topic modeling and we're trying to find the basic topics. And also we discussed with physicians. All those topics were designed with the aim of to understand COVID-19. At that time, we had very little information about this coronavirus. So for example, let me show you some representative topics like diagnosis. So what are the symptoms of COVID-19 and what are the diagnostic results? Right, is something related with radiology features. And for transmission, what are the characteristics of this specific coronavirus transmission? And what are the most like human to human? Forecasting, so for example, for modeling the epidemic, or for example, for estimating the trend. So that time we designed those topics, trying to understand this coronavirus. So along with the time, we have been also manually reviewing the growing literature. So for example, before there was no like official guidelines to talk about, for example, the control strategies or disease management during the pandemic. So, and then along the time, there have been more like guidelines, and then we have added the prevention topic. And recently we find there's also a rapid growth on the, specifically on the long COVID topic, it's for post-COVID conditions. So we have also added that topic. So speaking of long COVID, we recently had deployed this one in LeetCovid as well. So it's a new topic, and it has over 5,000 articles now. So this figure shows the basic characteristics of long COVID topic. So my colleague, Dr. Lehman, has I did a poster presentation yesterday. So if you're interested, please watch that video. While the topics have been used widely either in the LeetCovid or the downstream studies, frankly speaking, has been the primary curation bottleneck. So there's some variety of reasons. For example, compare with the other curation tasks in LeetCovid, like document triage and anti-extraction. So this type task naturally is more difficult. Each article can be assigned by multiple topics. It requires like the natural language understanding, rather than you can't simple text matching will not work. And in some cases, the curators need to manually read the full text to understand the exact topics. So here I want to show you like 5 examples. Those articles they have described, they all describe treatment-related information, but as for natural language, there have been a variety of variations or ambiguities. For example, some of the articles may describe this is a management option. Some of them may say, for example, is a promising targets. So while they all describe treatment-related information, they're using a diverse range of text. So this is all those reasons, and they have making the LeetCovid topic annotations very challenging. And remember, we are doing the curation every day in LeetCovid. So that's the main bottleneck for the curation pipeline. That's why we are here. So we present Biocreative LeetCovid track. The aim is like we want to call for the community effort to tackle this specific issue. So so the LeetCovid track has been designed to tackle automated topic annotations for the COVID-19 literature. In this specific track, we focus on 7 labels, and each article can be assigned to up to from 1 to 7 labels. So this is the brief timeline. It's started like about 5 to 6 months ago. So, we released the training and development set. And then after a month, we released the evaluation script. Along with the time we did the webinar, we released test set. And then the teams have about 20 days to prepare the test sets predictions and submit. And then recently, all the teams have finished their system description papers. The data sets are publicly available. So all the topics are manually curated. So the data sets contains the articles, the annotated topics, and also the metadata like title, abstract, journals, publication types. The training and development sets contains over 30,000 articles. The testing data sets contains 2,500 code sets. That's the independent set from the training and development set. So given the scale, so to our knowledge is one of the largest multi-label classification data set in the biomedical domain. Speaking of evaluation, so the scripts are also publicly available. So there's a detailed instruction to set up. So they also have sample documents to run to compare with the results. So existing studies on multi-label classification, they focus on both label-based and instance-based measures. Label-based, for example, the LeetCovid track has 7 labels. So it will measure the performance for each label and shows the overall measure. And for instance-based, in contrast, it shows the performance at document level because each document can be annotated by multiple topics. And F1s have been the most popular matrix for multi-label classification evaluations. So I will not talk about the detailed formula for precision recall F1 due to the time, but essentially for label-based, we used macro and micro-based F1s. So the difference is that the macro-based F1s is it treats all the labels equally. So it's a simple average of all the performance for each label. In contrast, micro F1s is a weighted average by the number of instances of the label. And for instance-based of F1, so it's the idea is similar, but the formulas are different. So for example, you need to calculate precision recall at each document level. For example, you have YI that stands for the predicted topics, and YI hat stands for the goal set and data set annotated topics. And then you do the intersection, divide by the number of predicted topics or the gold standard set for precision recall, and then you can calculate F1. So the script also provides other precision recall as the additional measures. We used MLNet as the baseline model. So this is a deep learning approach which achieved the best performance on biomedical and clinical multi-label classification tasks. It has been it's open sourced, so everyone can directly use it. And also for the previous, it has been achieved robust performance on standard multi-label classification data sets in the biomedical and clinical domain. It has two components. The first part is the document encoder. It uses AML, which is a contextual based embedding, followed by LSTM and with attention schema. So, so basically it transforms the raw document to a document vector. Then followed by the second component, which is the label count. It counts the distributions of the labels, and it ranks the probability of the labels for each documents, and then finally give the prediction of the label. So far we have talked about the overview of the track. We talked about the evaluations and the baseline. So now let me talk about the team participations. So overall, there are 19 teams. They submitted 82 predictions in total. After we did the validation, so there were 80 valid submissions. So, and then we manually examined the methods employed by each submission. We find actually there's a diverse range of methods, from TF-IDF, stands for term frequency, inverse document frequency. That's the classic document representation approach, to transformers like a range of BERT models. This is the result overview. Remember, we used both label-based measures and instance-based measures. This slide shows the label-based measures. So the left one is the baseline performance, and then we show the mean and the mean performance of the team submissions, and also by the ranks. So for the baseline, so we find it's very close to the mean of the team submissions, but the median performance is much higher than the baseline performance, similar for micro F1. And we find this is consistent in terms of instance F1 as well. So the baseline performance is very similar to the team mean submission performance, and the median one is much higher. So that basically means many of the team submissions have done an outstanding job that give better performance than the previous state-of-art multi-label classification task in the biomedical domain. So this is the top ranked systems. So we ranked them by these 3 F measures, and we found actually the top ranked systems achieved high performance consistently by those 3 measures. So the track overview paper provides the complete results. So in the limited time, I will not go through all the results, but instead, I will do a quick method overview. So we find that top ranked systems, they have been using approaches, they have been using like transformer as backbone model, but they have been doing something beyond transformers. So for example, like Biopharma team, they have been trying to use the efficiency-based transformer architectures. For transformer models, they are effective, but they have a large number of parameters, and some of them are definitely redundant. And the Biopharma team finds that if they change the existing BERT model architecture to remove the redundant parameters, and actually in turn, it improves both effectiveness and efficiency of the transformer models. The DUT team, that's the Dalian University of Technology, it used the label distribution matrix. It tried to capture the correlations between the labels. So for example, I think I remember I showed you a figure on the co-occurrence of the topics. Some of topics, they have been co-occurring frequently. So it's the DUT team tries to use the distribution matrix to capture the relationships, and also it used the customized feature representations for different fields of articles. The Obsidia team has been doing an extensive document data augmentation approach. For example, they did some masking, they tried to add some noise to mimic zero-shot learning approach. They have also done a meta ensemble using the Hamming selection. The donut NLP team. So this has a very sweet name, and I really need the donut. It's from the Taipei Medical University. So it combines the manually engineered features and with ensembles of BERT models. And we have the PolyU team. So that's for Hong Kong Polytechnic University. CBS is for Chinese Bilingual Study. So as organizers, we have been trying hard to memorize all the team names. It does a similar approach. So it's like ensembles of different variants of BERT. So the first 4 teams will present after my talk. So they will give you a detailed overview, and the Poly team. So we are also did poster presentation yesterday. So if you're interested, please do watch it. So in conclusion, so we have 19 teams submitted 80 valid test set predictions. So about 75 of the submissions, 75% of submissions have done have a better performance. That means most of them have done an outstanding job to have a very strong baseline for multi-label classification in the biomedical domain. So here, on behalf of all the organizers, we want to thank you to all the team participants. It's about 5 to 6 months dedicated work, and we have been communicating almost every day. Even we can't see you in person, we can pick up your names immediately. So we appreciate your support, and same for all the tracks. Is you made those tracks successful. So in the future, we plan to incorporate top-ranked systems into LeetCovid curation pipeline, which trying to make this pipeline more sustainable. So we want to thank all the organizers and our PI, and also all the BioCreative organizers. So our group have some open positions available. So please contact our PI, Dr. Jun Lu. This research was supported by the Intramural Research Program of the National Library of Medicine, National Institutes of Health. Thank you so much for your attention. I'm happy to take the questions. Thank you.
Thank you, Jingyu, for that overview of the track. It was we had a lot of teams who participated, and you were surprised to see results. Quite a few of them actually performed really great and over the baseline. And we have some teams that are going to talk next. But before we do that, I would like to just remind the participants that many of our teams have prepared short talks and introductions to their systems, and they are available on the YouTube channel. And the links are at the BioCreative website. Of course, the proceedings are available for all the tracks. And because it is an online meeting, we only are meeting for a short time, but these meetings are recorded and they will also be available. Now, let me start the floor with a couple of questions for you, Jingyu, about track 5. And meanwhile, we're opening the floor. So if you want to know more, now is your chance to ask Jingyu direct questions. So the first question, what do you think the remaining challenges are in topic classification?
Yeah. So there was one, I think there are a few remaining challenges. One particular one is for example, if we want to incorporate or apply topic classification for long documents. For example, for this specific challenge, so we are basically doing at abstract level. But in some of the cases, the topics, they are not sufficient to interpret from abstract only. The curators need to manually read the full text. So how do we, what's the effectiveness of how to apply those methods at the full text level is still a remaining challenge for that.
Right. Because sometimes the claims in the abstract may not be, maybe a little bit not precise, or a little bit exaggerated in what the paper covers. Yes, going into the full text is a good challenge. I have another question for you. What will it take for inclusion of Teams methods into a pipeline?
So I think there are two aspects. One is for because the top ranked systems, they have done a robust performance on topic classification. So one thing, if we incorporate those methods, it might further improve the effectiveness or assist the curators for topic annotations. The second one is like we want to measure how the real-time efficiency of those methods for in production setting. So because every day we have about like the medium is about 320 articles in LeetCovid every day to annotate. And then, so this one, for example, we want to see some of the methods may, for example, they have, we want to measure the efficiency and how to make this curation pipeline sustainable. I think those are the two aspects.
Right. And do you just talk to us about the data and how we have incorporated both manual annotation as well as the machine learning aspect into being able to sustain? Because in 2 years, we have more than 100,000 articles in this collection, which is useful for the community to have them classified with these different topics, even though they are very general topics. We do have a question with regard to people wanting to know some more details on how long does it take to manually annotate the topics, and maybe you could elaborate a little bit more on how this data is worked out.
That's a great question. So I don't think we have an exact time we measured by on the curators, because and also the number of articles they range dramatically for every day. So we could do a case study on the curation sustainability for with the machine learning model assisted or with the purely manually approach to see how it performs. But I can tell you, for example, for curators may spend like a few hours if they it's full manually annotated approach for topics.
Every day, dedicated. Yes, absolutely. I see that.
And Result has been doing extensive has extensive experience in the curation. Yeah.
Right. Yes, absolutely. I've been very I'm very familiar with what it takes to annotate and how much help in annotation system the annotators need to use their time as efficiently as possible. And we have done a lot of work there, but still there is some aspect for the human that we cannot we still need the human brain to be able to look at the data and give us their expert opinion. So this is a multi-topic label classification problem. It's fairly technical. So one would think that these methods could be extended to classify other journal articles for other collections, for other research areas, correct?
Yes, absolutely. So it's essentially it's still a text classification framework, and all the methods have been proposed has been generic. So, for example, if they have customized topics to or labels for classify, those models can be fine-tuned or adapted to the specific collection.
Right. So given the new data set and the number of topics that we need to classify them into a bit of tuning, it should be easy to transfer these models to the new research area, which is exciting and makes the contribution of this task for applicable to other areas as well, because it's in a sense, the proposal is a model that can be adapted to different areas. Well, it looks like we have gone through all the questions that have been posted so far. Jinyu, would you like to? I know we have 4
There
teams.
is a question in the Q&A, I think, Resarta.
Right. We have one more. Oh, this question is about the evaluation methods. Jinyu, you described in your overview talk the F1 metrics of how you evaluated the models. I know you applied 3 different ways of measuring the method's performance. Would you like to elaborate a little bit more on that?
Yeah, I saw this question. So it's about just for my understanding of technical matrix F1 score. So I think it's implying that we used so because F1 score is like a standard matrix for text classification. So we're trying to use from 3 aspects. One is like macro and micro-based label-based classification. That's kind of the most popular matrix for standard text classification, because this is also a multi-label approach that each document can be assigned by multiple labels. So we also incorporate with instance-based F1.
Right, so we have 3 ways of measuring, but we have selected the F1 as the standard way to evaluate the methods. We do have one more question, and we do have a couple more minutes, so I would like to give this to you as well. Will the standings of all the teams participated be available?
Yes, so they're already available in the overview paper.
Yes, so please go to the proceedings and you can have the very detailed tables for all the participating teams. Great, thank you, Jinyu. Now I'm going to move on to present the teams that we have invited to share with us live their methods. And if you can help me, Jinyu, present our first team. We are calling on the Bioformer team.
Yes.
They are going to talk to us about efficiency-based transformer architectures that remove redundant parameters and improve both effectiveness and efficiency of BERT models. We were impressed by their work, and they did show that in all the metrics they were ranked really high, and their the speaker for this team is Feng Li.
Thank you, Rosetta.
Go ahead, Feng.
So, can you see my screen?
Yes, yes,
Okay,
we can.
great. So, hello, my name is Li, and I'm a postdoc in Children's Hospital of Philadelphia. Thank you very much for inviting me to give this presentation. As Jinyu has mentioned, COVID-19 articles are growing very quickly, and we also observed a rapid growth of new articles in PubMed, especially in the recent 2 years. Therefore, fast and accurate biomedical text mining is needed for large-scale knowledge extraction or data organization. There are pre-trained transformer models like BERT, XLNet, or ALBERT. They achieve state-of-art performance on general domain NLP tasks. And recently, BERT models have been adopted to the biomedical domain. For example, we have BioBERT, BlueBERT, or PubMed BERT. And however, these models have more than 100 million parameters. Applying these models for large-scale text mining tasks is computationally expensive. To address this, we pre-trained a fast and lightweight BERT model, which we call Bioformer, compared with a typical BERT-based model. It has less number of layers and a smaller hidden size. For example, here, BioBERT has 100 million parameters, and Bioformer only has 43 million parameters, and BioBERT has 12 layers, but Bioformer has 8 layers. And Bioformer also has a smaller embedding size, which is 512, while BioBERT was 768. By reducing the number of parameters, the speed is improved to 3 times. And in addition, BioBERT was pre-trained using a continual pre-training strategy, which means it took the checkpoints from Google's BERT and then continue pre-training on the biomedical domain. But Bioformer was pre-trained from scratch on the biomedical domain. And since it's faster, so we can train more epochs given the same computational cost. So BioBERT was pre-trained for 1 million steps, and we pre-trained Bioformer for 2 million steps, and we used a slightly larger batch size. So as a result, Bioformer was learned 3 times more training examples during the pre-training stage. And to address the lead COVID challenge, we performed additional pre-training on COVID-19 articles. The pre-training corpus is composed of abstracts of COVID-19 papers from the lead COVID database. So we download the abstracts from the COVID database and pre-train it for 100 epochs on Google's Colab. And this pre-training process was finished in 8 hours. We denote this model as Bioformer lead COVID. So to address the multi-label topic classification problem, we formulate this problem as a standard sentence pair classification problem. And we use the title as the first sentence and abstract as the second sentence. So the input sentence was presented as the CLS title, SCP abstract SCP. Here, CLS is means the beginning of the sentence, and also can be used to classify the topic of the sentence. And SCP indicates a separation between 2 sentences. We tested 3 models, Bioformer, BioBERT, and PubMedBERT, and we trained a binary classification model for each topic label. So we trained 7 models for each for the lead COVID task, because there are 7 labels. And for the fine-tuning settings, we fine-tune for up to 5 epochs, and using a batch size of 16 and learning rate 1 to the 1 - 5. Here is the performance on the development set. So we have 5 models here. The first one is the original Bioformer, and the second one is the Bioformer pre-trained on the lead COVID articles. And we have 2 versions of PubMedBERT, which is, the first one is PubMedBERT AB4. The AB4 means it was pre-trained on both abstracts and full text. And the PubMed AB version was only pre-trained on the abstracts. And we also have BioBERT. And here is the result. So because the numbers are very close to each other, so I added a ranking after the F1 score. Bioformer achieved a highest micro F1 and instance-based F1. in these 5 models, and Bioformer lead COVID achieved highest macro F1 score. And the 3 other models, among the 3 other models, PubMed BERT AB has the highest macro F1 score in our development set. And in terms of computational cost, Bioformer used less number of parameters, and therefore the speed is about 3 times as fast as BioBERT or PubMed BERT. So we see, here is the we've submitted 5 models. So the first 3 models, they are fine-tuned on the same dataset, which is the training set provided by the task. So we can do a fair comparison between the 3 models. And we also submitted a model that is fine-tuned on the combination of training and development set to potentially increase the performance. And we also tried another submission, which is based on the labels from the lead COVID website. So we downloaded the abstracts and their labels from the lead COVID abstract and trained Bioformer on this dataset. Also, sorry, due to the limited number of submissions, we didn't submit the models of Bioformer lead COVID. Here is the test set performance, which is the challenge results. So Bioformer, we can see that if we fine tune on the combination of training and development set, the macro F1 score is slightly improved and is highest among our submitted models. And among the 3 models that was trained on the same dataset, we can see that Bioformer has the highest micro F1 score and instance-based F1 score, where PubMed BERT has highest macro F1 score. And it turns out that the lead COVID website contains some annotations that are not manually curated, but using text mining tools. So the labels from the lead COVID website is not a gold standard. So the performance is a little bit lower than the other models. But all the 5 models provide significant improvement over the baseline model. In summary, we presented Bioformer, which achieved a slightly better performance than BioBERT and PubMed BERT, but with much faster speed. And Bioformer is compatible with Transformers library and it's available on Hugging Face website. We hope that Bioformer can be used in more real-world projects in the future. I would like to thank my advisor, Professor Kai Wang, and all lab members in the Wang Genomics Lab. And also I would like to thank the TPO research program by Google. Thanks for listening.
Thank you, Bioformer team, for that presentation.
Thank you.
We already have a question, and you can also see that in the question and answers. How did you split the training set to have data for each class, one versus all, within the binary classification?
Oh, okay. So the track, the organizer already provided labels for each class for each abstract. So if an abstract has a label, then I assign it to be 1, and if the abstract do not have that label, then we assign it as 0, and then do a binary classification for each label.
Right. I hope that was clear. But if you have a follow-up question, please utilize the chat or the Q&A. I'm going to move on to another question that we have on the chat. Have you compared the performance on using title and abstract for direct classification versus title and abstract as the sentence pair?
Oh, so I didn't compare these two, the performance of these two input, because when we were working on this, there was very time left for submission, and but actually I compared the performance of using only abstract and using title plus abstract, and there is a performance improvement by using title plus abstract compared with only using abstract.
Okay, yeah. So it seems like there's even more work that could be extended and done after the challenge.
Yeah, we can do more work.
Thank you, Feng Li.
Thank you.
And thank you for presenting us your method. I do have a follow-up question. Let me take this real quick, and then I'm going to move on to the other presenter. So the question is, and you haven't had the unbalanced sets with this way of splitting?
So for the unbalanced set, it's still splitting in this way. So as a result, we will have a lot of negative labels and very few positive labels. For example, for a case report, there are very few positive examples. And by splitting this way, actually, yes, many examples are negative and very few examples are positive. And so for these topics, the performance was not as good as other topics, but we may try other ways to improve the performance on these topics later, after the challenge.
Okay, thank you. And
thank you.
Please, you can continue to ask your questions. Please use the chat box, and I'm sure Feng Li will write the answer in real time. I would like now to call on the DUT 914 team. Ventai, their methods. This team describes a label distribution matrix to capture label correlations and customized feature representations for different fields. So we're excited to hear from them. Please take it right now.
Okay, can you see my screen?
Yes, we do see your screen, and we can hear you very well.
Thank you. Hello, everyone. We are team DUT number 5 from Dalian University of Technology. Today, I'm going to talk about this track, the multi-label topic classification for COVID-19 literature annotation. Our team proposed a bio-based feature enhancement approach for this task. This is the outline of this talk. And the first part, we want to introduce the status quo of this task. And second part, we introduce our method in details. And next part covers the empirical results and giving a simple conclusion. The task is a multi-label topic classification for COVID-19 literature annotation. The rapid growth of biomedical literature poses significant challenges to manual curation and interpretation. This challenge has become more evident during the COVID-19 pandemic. Categorizing the available literature plays an important role in managing the flood of information. And this track focuses on multi-label text classification of documents on COVID-19. And each article in the dataset is labeled with 1 or more up to 8 categories, which is a document-level multi-label classification task. Increasing the accuracy of automated topic prediction in COVID-19 related literature would be a timely improvement beneficial to curators. So in this track, our team has achieved the instance-based precision of 0.935, the recall score of 0.9438, and the F1 score of 0.9394. So when we have this task at the beginning, we first perform a data analysis on this data set, and we observe that the length of abstract is several hundreds words, and we need to deal with the long text properly. And we also observe that the length distribution of title and abstract is imbalanced. The length of titles is shorter than that of abstracts. It is well known that titles condense the whole article. So we want to find a way to use the title informations, which means that the short titles often contain greater information at the same length. So we have three challenges here. The first is how to choose an effective encoder for document level data. And the second is how to use short but informative article titles wisely. And last, how to make use of label information in the training set. And here's our answers. For the first challenge, since the length of each instance is much longer, so BERT and its variants perform well on long text representation. So therefore, we have tried different BERT-based models and chose the BioBERT as the basis. And for the second challenge, upon the imbalance distribution problem, we try to reuse the title information, and we want the model learn more things from the titles, and we design a new method dealing with that. Specifically, we additional encode the title and put it behind the output of the BioBERT encoder. And for the third challenge, to further enhance the performance of the model, we try to incorporate the label distribution into the model. Here is the distribution of labels and how we obtain the corresponding distribution matrix. So specifically, we count the distribution of labels in the training set. For example, we count the total number of occurrences of the first label, so represented as M, then divided by co-occurring number of both the first and second label, and the result is the correlation value of the first and for the first label and the second label. After that, here is our model. This is the processing flow of our model. It includes three modules: text processing, feature processing, and feature enhancements. In text processing module, it aims to obtain the input format required by the model. First, we extract the article titles and abstracts from the dataset. Then the article title and the abstracts are concatenated as the first input part. Additionally, we want to reuse the title information, so we only take the article titles as the second part. The second and then we calculate the tag association matrix based on the distribution of labels. And the second module, in feature processing, it is designed to achieve feature equalization. The first input part, which consists of the title and abstract, in tokenized and then encoded by BioBERT. The second input part, including only the title, is embedded randomly. Then we concatenate the process features and the tokenization of the title to obtain the equalized features. And in feature enhancements, we use the label distribution of the training set to obtain a label distribution matrix. By introducing this matrix into the model, the label information is incorporated. Previously, we have obtained the label matrix here, and then we multiply the equalized features by the label matrix and to obtain the final output. And here is the task results. The left table shows the results of our task. Our baseline is provided by the organizer. To effectively handle the document level data about COVID-19, we use the pre-trained model COVID-BERT with 4.5 modules above the baseline. And after comparison, BioBERT has better results on its datasets. Therefore, we choose to improve the model based on BioBERT. And then compared to BioBERT, only using the abstract, our model was 2.19 points higher. And finally, the F1 of our model is 7.16 points higher compared to the baseline. Specifically, the results for each class of our method are shown in the second table. To analyze the effectiveness of our method, we conduct additional ablation experiments, and the results are shown in this table. Experimental results show that the F1 of our module improved by 1.05 points after adding our feature processing method to the original BioBERT. And in addition, the F1 of the model improved by 1.19 points after adding our feature enhancement method. Finally, the F1 of our complete model is 2.19 points higher than F1 of the BioBERT. It demonstrates that the effectiveness of our improved approach we have devised for this multi-label topic classification of COVID-19. And last, the feature enhancement method we designed are proved to be effective. We achieved that the BioBERT-based model encodes document level data efficiently. And the feature balance method we designed can improve the effectiveness of the model. And last, incorporating the label information is an effective way. This is the feature enhancement method. And thanks for your attention.
Thank you, Wentai. That was a great talk. We are open for questions.
Oh, okay.
I have one for you. And we have a couple of questions. Feng Li is busy typing his answers on the Q&A, but we can take questions for Wentai Tang now too. I'm reading the first question to you. Will the label matrix still be effective if the test set has different label distributions?
It depends. We just want to use the label informations, and we try that. I think if the text is different from the distribution of text of tested set, if the distribution of tested set is different from the trained set, I think the results may have different. This may have different results, but I think the way of using the label information is useful because the way of splitting the training set and the test setting, we have a basic assumption is they have the similar distribution. So I think so the use of the label informations can be effective.
But it needs some more research on how to best leverage that information, right?
Yeah.
To make sure that the method is robust enough to translate and to withstand different distributions, unexpected distributions in the testing set. Yeah. It's always a problem for any method. Yeah. Thank you. I do have one more question, so I'm going to take this and then I'm going to move on to so I'm going to give you 1 more minute for this. The question is, was your final model fine-tuned, trained on both the training and the development set?
Yes.
Yes. So you found it useful to use all the data that you had to fine-tune the model. Okay. Thank you so much, Wentai. And please continue to utilize the Q&A boxes and the chat if you want to keep asking questions to the previous 2 speakers. Meanwhile, I'm going to transition us to the Obsidia team. Rakuten will be our speaker. They will talk to us about masking zero-shot like noise addition approach and meta-ensemble learning using Hamming selection. The floor is yours.
Do you guys hear me?
Yes, and we can see your slides too.
Okay, nice. Okay, so hi everyone, my name is Loïc Rakuten and I'm a junior machine learning engineer at Obsidia in Paris. And I'm going to present to you the experiments that my team and I have done for this track 5 of this 7th edition of Biocreative. So we first explored the Lake COVID dataset by projecting the distribution and similarity between articles in 2 dimensions by applying TSNE. And from this knowledge, we noticed the imbalance between the categories in the publication, as well as the categories that are often linked. And on the other hand, we further analyzed each category to highlight subclusters and frequently applied themes using term frequency. So from this exploratory analysis, we deduced the difficulties of the task, which are confirmed by our first experiments, namely the difficulty to classify the categories and the linked groups more often underrepresented, as well as the robustness of the model due to small quantity of data. So we conducted our experiments based on the wisdom of crowd theory, i.e. on the ensemble methods, and more precisely on Bayesian by compensating the data imbalance. The LeetCovid training data contains 25K imbalanced rows with sometimes missing parts, especially the keywords. And we also noticed that labels tend to put high weights on particular parts of the text. So we played with the order of the fields, where the last field is often truncated and therefore hidden from the training data. And secondly, as all the articles are related to COVID-19, we added the option where all the terms related to it are hidden and masked, like coronavirus, COVID, virus, and so on. Finally, we have the option where we have increased the vocabulary of the dataset by random substitution of words by synonyms or close expression while remaining in the subclusters that we have previously identified during the exploration in TSNE. And altogether, we have 8 different combinations, so 8 more or less dependent but representative new samples. As a consequence of the imbalance, the minority class are quickly learned from the first epoch, which then overfit until there is the optimal weight of the overall set. And in our case here, the F1 instance is dotted and the optimal weight is at the 31st epoch, where the 4 labels have 4 labels, which are epidemic forecasting, transmission, mechanism, and case report have already been overfit. And we can see that there are weights that are specialized in the prediction of a defined label. So we considered each weight of each epoch as a submodel, the weak learner, although the difference is not really expressed. We then selected models based on BERT and Roberta, pre-trained on corpora closest to our case, which are PubMed, Clinical Report, Core19, and Semantic Scholar. And we fine-tuned the fine-tuning of these models showed us that some models are also specialized in defined labels. For example, bioclinical is the best for predicting diagnosis, PubMed BERT for mechanism and transmission, and so on. So to build our models, we trained each model in parallel on the 8 samples, which makes 40 models trained in parallel. And each epoch of each model constitutes a submodel. Then follows a second block, which theoretically assigns weights ranging from 0 to 1 to each submodel according to their scores. However, in practice, we have opted for a selection of submodels according to the Hamming loss on validation set. And this means that all the selected models are given a weight of 1 and the others a weight of 0. And this selected model constitute the meta model whose prediction are the subroutine of the ensemble. Then we monitor the evolution of the meta model construction and its performance, and we submitted each of its evolution. And we can see here in the figure 5, we noticed that all alternative meta models perform better than the classical training, whose curve is here in dashed in red. And the meta models also converge faster around the 20th epoch compared to the classical one. And the first step above here, which I call K-epoch ensemble, only aggregates the K-best epoch on the one of the 8 samples. And we have to note that the selection of the submodel must be done parsimoniously because the increase of complexity does not go directly with an increase in performance. And here with the set of K equal to 3 best models and 8 best models, they reached their best score at the 18th epoch, but in overall, the simplest model outperforms the most complex. The upper level here, which I call a sample method, use the pure Bayesian with the top 1 epoch of each of the 8 samples. That is to say that at epoch n, we take the best of the n weight of each of the 8 submodels and we average them. And we obtain the expected result, namely the robustness of the model to the new concept it encounters. So we use this model for our first submission, and we named it the PubMed here. The results are on the right on the table 1. And the last step uses the key epoch method on the 8 samples. But taking the best 3 epoch of each sample, we have 24 epoch to average, which makes a too complex model. By selecting only the 8 best of those 24, we find almost the same performance with less complexity. And finally, we stack the heterogeneous models to go to the end of the meta model construction. So we have Meta Roberta, which is composed of the vocabulary of Biomed and Roberta base. And we took the top 1, then the top 3 of each sample, and we got there to performance in table 1. The MetaBird combines the vocabulary of PubMed, SciBird, and Bioclinical, but uses the weighted selection of epoch, the Hamming loss selection. And the final model here, the meta model, takes into account all the vocabulary diversity with the weighted selection and gives the best result of our submission. And to conclude, this last meta model that we have built has then the advantage to build the best representation of the article, despite the lack of information and complete parts of the content. To know when the subject is talking about COVID-19, even if it is implicit, and in another way, is applicable to all over topic other than COVID-19, but which revolve around the 7 categories in late COVID, and to be robust to new concept tokens and expression that are not included in the original COVID corpus in the training dataset. And it can be used raw as is in the current classification test, but we also see its use in the steadiness knowledge to give the richest representation to very lightweight and less complex model for similar tasks. And so ends my presentation on our experiments on track 5 in this edition of Bureaucracy. Thank you for listening.
Thank you, Loic. That was a really nice talk, and I appreciate how you went into this careful analysis, as if anticipating all the different questions that you might have, looking at your model in different ways and trying to work out what worked in different scenarios. I'm gonna give it a few more seconds to see if anyone wants to ask you more questions.
You can write it in the chat and I will
Yes.
later.
Yes, I actually encourage all of you to monitor both the Q&A and the chat. But I do have a question. Let me read it to you. The question is on the synonyms. How were the synonyms selected? Have you used biomedical embeddings to find similar words?
Yes, we first experiment with WordNet. So we use WordNet synonyms, and for expressions we used Roberta. BERT base, the general BERT base. But theoretically, we wanted to use the average of each TSNA clusters.
Okay, thank you. And I'm gonna let you look at the chat and answer. Meanwhile, I'm gonna call in our last talk for this track. It's the Donut NLP team. The speaker is Shengji Lin, and we are excited to have her talk to us about manually engineered features and ensembles of BERT models, which were characteristic of their method. Can you turn on your mic?
Can you hear me?
Yes, and we can see your slides.
Okay, let's start. Hello, I'm Shengji. I behalf the NLP team from NLP Lab of Taipei Medical University in Taipei, Taiwan. As you can see the screen, our topic is multi-label topic classification for COVID-19 literature annotation using the BERT-based ensemble learning approach for the Biocratic 7 COVID track. Oh, sorry. And why need to do topic classification for COVID-19 literature annotation? Firstly, scientific articles on COVID-19 and SARS-CoV-2 are published rapidly since the outbreak of preventive pandemic in 2020, with about 10,000 new articles each month. Researchers, healthcare professionals, and even the public are finding it incredibly difficult to stay on top of the latest research. In order to solve this serious problem, LeetCovid, a curated literature hub to track up-to-date scientific information in PubMed, has been developed and called for a community effort to tackle automatic topic annotation for COVID-19 literature. The task of automatic topic annotation for COVID-19 literature can reduce human effort and increase efficiency. And our method to predict a topic of COVID-19 literature, we use pre-trained BioBERT model as the basis of our system. And why BioBERT? First key technical innovation is applying the bidirectional training of transformer, a popular attention model to language modeling. Moreover, BioBERT is a domain-specific language representation model pre-trained on large-scale biomedical corpora. We almost the same architecture across tasks. BioBERT largely outperforms BERT and prefers state-of-the-art model in a variety of biomedical text mining tasks when pre-trained on biomedical corpora. The different systems we developed for this track are described as follows. Here, we use submission ID as the name of the method. The first one, BC7 submission 14. Since the BioBird model is efficient in biomedical NLP tasks, we use ensemble learning with the majority 14 mechanism to integrate multiple BioBird models, which are selected through K4 cross-validation for this submission. The next, BC7 submission 43. We investigate the performance improvement by merging different of the bird model. In addition to BioBird, the Sultan is the latest bird model published in 2021 and achieved state-of-the-art on several biomedical NLP tasks. The Sultan model is built from the electron architecture and trained on PubMed abstract with biomedical domain vocabulary. In the end, we investigate Sultan with two different versions of BioBird through a majority 14 mechanism. And the third, we observe that the data is imbalanced. We indicate an unequal distribution of classes within a data. To handle the data imbalance issue, we say the class weight on the final layer of the biomedical classifier is inversely proportional to their representative frequency. And the next, we BC7 submission 14 to put extra features from section labels such as title, abstract, and table. More specially, we update essential labels through extraction pop test of extent in the data set, concatenated with the term embedded. And the last, we adopt ensemble learning to merging multiple Sultan models selected by K4 cross-validation. And all results shown on screen. Firstly, we apply grading search to test hundreds of biorelated bird models and show the top 5 models in this compaction. We inference because they are all trained by the PubMed text that recovery update daily with textual information from. Especially BioBird V1.2 achieves the best performance among the older models. We also carry distinctly different model architecture to find the better one for more factory adjustment or better environment setting hyperparametrity. Moreover, using the 5-fold cross-validation as the model selection approach for multiple BioBird further increasing data using a majority voting mechanism performs very well in this compaction. Finally, the experimental results on the test day are shown in table. The organizer providing submission relaxed tactics that contain the mean, standard deviation, Q1 median, and Q3 of a measure for all submissions. And NLNet serves as the baseline model for a comparison. As shown in the table, all of our models clearly outperform the baseline with an about 7% relaxed increase in instant-based F1 score compared with the best result of the baseline. Besides, it is worthy to note that instant-based F1 score of all best model outperform Q3 of the measure for all submissions by almost 1%. In the official result, always achieve remarkable performance with precision, recall, and F1 score of 94.4%, 92.5%, and 93.54%, respectively. In light of our experiment, it proved that using pre-trained models are effective in predicting topics about COVID-19 literature. Moreover, the effect of ensemble learning with majority voting mechanism for the pre-trained model is investigated. The outcome suggests that ensemble learning is effective improvement the performance of our model for the COVID track. However, from our error analysis, it concludes that our model may be further improved by considering additional information such as keywords, which are finer scale than pop type, and external knowledge base. This direction will be explored in our future work. And our donors NLP member is here. The end. Thanks for listening. I'm Shenjue from NLP Lab of Taipei Medical University in Taipei, Taiwan. Thank you.
Thank you, Shenji Ling, for this informative talk. I appreciate all your analysis and your description of your method. I do have a question for you. Would you please talk about how you selected these bird models for the ensemble learning?
Okay. Because we test hundreds of bioreactive models to train the model. So we select the top 5 models and choose and ensemble all the models to compare their performance, and the final we chose the best 5 performance model to submit or answer.
Mm-hmm.
Mm-hmm.
Yeah, and I have also another comment here, which thank you for the presentation. And they like your cross-validation to address the imbalance problem in the data. Okay. And again, I want to thank you, Shenji, and the previous speakers. We have reached the end of this session. I was happy to have you all here and talk about the methods. This morning and today is dedicated to the COVID-19 topics, and we will go in a short break now for about 15 minutes. Please come back for the interactive track at 11:15. Thank you.
Hi, Chris.
Yep.
Can I check to make sure I can actually play a video for, I think, Amy Alex, whose internet died?
Okay. So remember, bottom left, optimize for video. And you open the share screen window.
Okay.
When you share your screen, at the very end, you have checkboxes.
Yep, got it. All right.
Hello, my name is Amy Olex, and in this presentation, I will be giving an introduction.
So
Sorry, what?
Instead of sharing your desktop, why don't you pick that actual program that's running the video, or even if it's like Chrome or Safari or whatever, choose that instead of your desktop, because we are seeing like, your stop share. We're seeing like your full screen, your view.
Oh, huh.
So when you open up share screen, since you checked it once, the optimize for video should still be there, but on the top left, that's your desktop. That's probably what was chosen. So look around for where the video is with all your choices, and then
okay, I'm let me all right, first of all, I should stop. Oh, okay.
Yeah, no, that stopped you.
Okay, blah blah blah. Oops, it's the wrong one. Sorry. Okay, and all right, you're telling me I'm not seeing my.
Yeah, sometimes the picture doesn't match. So if you read the actual like applications,
I don't, whiteboard? Doesn't seem like,
Whiteboard. Like, what are you playing it off of?
I'm
Streaming or
playing,
is it-
I'm playing it off of, it's an MPEG-4 file and I'm just
Yeah,
opening it. And
if you want to share and do desktop, maybe I can see what's playing.
all right, hang on a second. All right, share screen. Ah, there it's showing up as a QuickTime player. Okay. That should be better.
Okay.
Hello, my name is Amy Olek.
Okay, is that better?
Yeah, unfortunately, there's a Zoom glitch, so we're seeing what I'm assuming is your control bar on the top. We're seeing like a gray box. So let me unshare you. So what I want you to do, uncheck the optimize for video. Do the same share thing. So open up your share screen,
Yep.
uncheck optimize for video, make
Yep.
sure that's not checked.
Okay.
And then don't start playing, but pull up the QuickTime.
All right.
And then
with
share your QuickTime.
Yep. Now it's really in some very strange state. I'm sorry. Let me, all right. I'm gonna share screen. I'm gonna unclick optimize for video.
Correct.
I'm going to
Find the QuickTime window. Okay, there you go. Now on your control bar where you see the like stop sharing and view options, it's the small bar.
Yeah.
We don't see it. So click on view options and it should have the optimize for video there.
Stop sharing and view options.
Or even I think on the share on your control bar where you had the share screen, there's a little caret next to it. I think it's under the caret too. You can do
Subtitle full screen.
you should be able to see somewhere the
Yes. Okay.
again.
So now I should click optimize screen share.
Yeah, it's a bug in. Oh no, it brought it up. I thought that usually fixed it. You know. Well, unfortunately, we're going to see probably a little gray rectangle on top, but that usually fixes it. But Zoom still has some bugs here and there.
And in this presentation.
Okay, but the sound is working.
Yeah.
So she mentioned she's going to the office, so maybe we can start with the second speaker, and then if she joins in, we wait until. What do you think, Lynette?
I think that's fine. We can certainly let her know that, I guess I need to let the following speakers know. She's all right, Andrew's giving an intro. The second one is preview. She is the third one. We could certainly bump the others up. So
yeah, I predict she will be in on time because she said it takes her 30 minutes and that was a few minutes ago. And we still need to listen to Andrew and
yeah,
we'll see.
Okay, I'm going to stop sharing. I will let the other speakers know. I guess the other speakers may be on listening.
I think Ilya is the following one, so he should be ready in case.
Yeah. Ilya, are you there and can you, is it okay if we move you up in the order? I can.
Yes, that's okay.
Okay, great, thank you. And I see
Yeah,
that,
so what's my position in line then?
you will be after Johannes Darms for the preview. So you're not there. Andrew's giving a short intro. Johannes is talking about preview, and then you would be up talking about Agatha. Is that correct?
Yes, yeah.
Okay, and I will also tell Ben that he is going to be after you, and we'll just, Ben, are you okay with that?
Might not be there.
He's just unmuting. Ben?
I might have done that.
Oh. Well,
Yeah, usually, if they don't give me permission, it's to ask to unmute, but
yeah. All right, I'll send him a message.
No comment from Ben. And Lynette, you'll be doing the introduction before, right?
Yeah. Yep.
Is Tanya coming in later too? I'm not seeing her.
Yeah. Tanya should be there. Since I'm having so much trouble, Tanya, you might want to just check your, playing your video.
Tanya's not in the room. That's what I'm saying. Yeah.
Okay, I'll try to raise her.
I feel like she tested earlier. It might be
Okay, she may have. I joined a little late this morning, so.
I can send her a message if you want, an email saying that.
Okay, and so maybe I'll just announce that up front at the beginning of the session too, that we'll just to be on the safe side, we will put Amy Alex at the end, okay? And that will give her the most time to, but before Andrew, obviously. Which suggests that I should have a slide where I can show that.
Did you guys see the message from Ben?
Yes.
Yeah.
Lynette, I put the new order on the chat box. So in case you want, no problem. Sorry, I forgot to put Andrew should be at the very last, so make sure.
Okay, I'm gonna try to make a very quick slide of this.
I sent a message to Amy saying that we moved her at the end before the discussion, so she's aware.
Okay, before Andrew's closing.
Yes,
Yeah.
yes,
Thank you.
no problem.
Okay, and okay, I'm just missing Amy here. Oop.
Lynette, maybe you should mute, and then when I see you unmute, quarter after, I'll spotlight you. Sound okay?
All right, I think we are back from break, and I want to welcome you to track 4, the COVID text mining tool interactive demonstration task. We've had a little bit of reconfiguration of the agenda, so I'm just going to put it up here very quickly, if I can figure out how to do that. All right, this is the new agenda because one of our speakers had her internet die in her whole neighborhood. So we have reconfigured. So we will start off this track with an introduction by Andrew Chaudhary-Aryamontry. I will just make a quick comment before we turn this over to Andrew. Namely, we have done interactive tasks and tracks before, but we have not done one that did not have a specific application in mind. The past tracks we've done have been mostly focused on literature curation for biocurators. So this is a new exploration for us. So we are very excited about presenting this, and I will turn this now over to Andrew.
Thank you, Lynette. Can you hear me and see?
Yes.
Okay, perfect. Welcome everybody to the Biocreative track 4 session. As Lynette was mentioning, you're gonna hear about the evaluation of text mining tools conceived for supporting COVID-19 research. Let me provide you a little bit of a background on why an interactive text mining task. What is the motivation? One of the main motivations was to allow developers and users, communities that usually don't have many opportunities to communicate, to provide a common space where they could have a two-way communication and where the users could provide feedback to the developers, and so to allow further development of their tools. We already held 3 editions in the past of this specific task, and another thing that we realized, as Ned was also mentioning, is that some of the tools were useful but not mature enough to totally replace manual curation, but they could be very supportive to different biocuration tasks. And so the 3 previous editions have been tightly related to biocuration, and all the various tools were asked to perform a specific task within the biocuration workflow, either being a triage stage or the relation evidence extractions like protein-protein interaction on the identification of phosphosites. This year is a little bit different, and we'll go into the details soon. So why a specific COVID-19 interactive task? So if you look at what could be an ideal way on how the biomedical sciences work, usually at the very beginning we have the sequencing of the gene of the model of organism of interest, and there is a number of automated annotations which are generated and made available, and then the most relevant part, which is the production of the experimental data. But this data doesn't become public until it goes around the peer reviewing. And from there, the data is extracted then by thematic databases and made available in a more computable format or in more searchable formats. Of course, with the crisis of COVID-19, there was no time to go through a full peer review for the data, and actually, what we can consider unorthodox sources, they become pretty relevant because allow a quick dissemination of the data. And so we had preprints servers, which are basically there are places to share preprint publications, which are publications which have not undergone the peer review process, or repositories for clinical trials. So this is a perfect environment for text mining to provide support, and also thanks to the prompt availability of COVID-19 specific corpora, there was a number of tools that was generated to support a large audience, so not just researchers or academia, but also clinicians, industry, and government officials. This is the track design was pretty much as it was into the other editions. But as Lynette mentioned, in this edition, we didn't try to ask to each system to perform a specific task on which to be evaluated, but it was more kind of an explorative exercise where each systems were evaluated for what it was offering. And instead of matching a sister with a group of testers that would be the specified end users, we try to generate a larger body of beta testers. But the main goal of the track remained there, so to generate user engagement and to provide feedback to the developers, and also to provide exposure to the tools. When we look at the participants, the testers, we had we think more than 30, because the testers were anonymous, so they were not required to provide the information. So when we look at the COVID expertise, we had 50% of the people involved into the evaluation had COVID expertise. Not surprisingly, the majority of the people was employed in academia. And activity-wise, about half of the group was involved in biocuration. Then there was the second largest group was made of bioinformaticians, and then there was other, where actually surprisingly we have people involved in urban planning research, social and behavioral research, but also biologists. About the participants, we had 7 systems that participated. We can roughly group them in 2 groups: search engines and reasoning tools. And they were using a number of different inputs, either clinical trials or Medline or preprint servers or patents, or a combination of these. And they were performing a number of tasks, including entity recognition, information retrieval, and topic modeling. I'll stop here. So we're going to hear from the groups that they're going to introduce their tools. We're going to resume later to discuss the results of this task. Thank you.
Okay, thank you, Andrew, for introducing this task. The first presentation will be from Johannes Darms, who's going to talk about the preview system. So over to you, Johannes.
Thank you for the introduction. Can you see my screen? You all can see my screen. Great. My name is Johannes Darms, and I work for the German National Library of Medicine, and I'm honored to present Preview COVID-19, a semantic search engine for COVID preprints. The software was developed within the NFTI for Health Task Force COVID project, funded by the German Research Foundation. We all know the COVID pandemic changed our lives drastically, and access to information become more and more important. And many researchers use preprint servers to share the results prior to the usual preview process, which can take up several months. And as a consequence, between 17 and 30% of all COVID-19 related research of 2020 were published as a preprint. The number of preprints published generally increased as well. But not only published preprints increased, also peer-reviewed publications were published in large amount. There was so much research published that the WHO classified it as an infodemic. But preprints has to be carefully incorporated into information infrastructures, as they're not reviewed, they're not cross-checked, they can be wrong. Many systems started to include preprints into the systems. But we believe, we believe that preprints has to be integrated separately. We cannot mix them. We have to have a system which provides access to preprint publications concerning COVID, but it should be different from those systems which include peer-reviewed articles. And therefore, we generated our system Preview COVID-19. Let me introduce you Preview in 3 simple sentences. Preview is a web application that aggregates more than 37,000 preprints from 7 different preprint servers. The data is updated daily and is freely available on our website, preview.zbmed.de. The system supports search functionality and corpus analytics through an automatic enrichment with biomedical annotations. Besides the user interface, we offer an easy-to-use web application programming API that can be used programmatically. But luckily, we have the honor that it's an online event, so I can show you the software live and show you what we developed. When you visit our webpage, preview.zbmed.de, you agree with our landing page. On the top, you can see the query builder, which allows you to ask or to state questions to our system. In the center, you see the result list. And on both sides of the screen, you see descriptive statistics of the result set, facets that can be used to refine the search. But let's explore the system on a running sample. In this case, I would like to search for publications that contain pneumia or talk about pneumia. Here we have the option to search for semantic concepts with an autocomplete feature. Here we can select pneumonia to search. Now my mouse is gone somehow. Here it is. You can search for it and return over 1,000 documents. That's a bit too much. I don't want to read all of this. So I can refine my search. On the left side of the screen, I have these facets which allow me to refine the search. In this case, I would like to refine my search for fever because it only contains 150 documents. Great, now I only have 150 documents included, but still a bit too much. I can further refine the search by stating query term. In this case, I would like to search only for articles which contain children as a search term. And as a result, I only get 12 results. That's something I can read. To read through all these articles, we have an option to expand all extracts. That allows the user to read all titled abstracts and information on a single page. So you can see the titles in abstracts are semantically enriched with semantic terms. They are highlighted. This highlight can be enabled and disabled. By clicking on a highlighted term, you can see additional information and alternative synonyms. In this article here, you can see a different feature we developed for the BioCreative EAT track. We integrated the information whether a preprint publication is also peer-reviewed published. So there is a duplicate which was checked by other researchers. You can click on it, will be directed to the peer-reviewed version of the preprint publication. We think that this feature is quite handy. This information whether a preprint publication is also peer-reviewed published is either obtained from the Crossref service, from the preprint server itself, or it's automatically detected by the pre-to-pub algorithm. Another feature we developed for the BioCreative challenge is our feedback mode, which can be demonstrated on this document here. Here you can see an annotation which is wrong. The annotation system missed the -c part to be annotated, which is a mistake, and we would like to improve it. Therefore, we created a system, the feedback mode, which allows the user, by clicking on a thumbs up and thumbs down icon, to send feedback to us so we can fix the mistake in the next version and train our algorithms. So we can click thumbs down button and the feedback is sent. Another feature we can offer is the export functionality, which is quite handy as well. I can export my result set as BibTeX or EndNote file. Now let me go back to our presentation. I would like to come to read the results of the Biocreative EAT track. We got feedback from 9 participants. Our feedback participants, or the feedback we got, was from people which were related to the COVID-19 research. They mostly work in academia or the government sector. They're biocreatives, informaticians, or work in experimental research. Most of the questions asked to the reviewers were free text questions where they provide us their wishes, features, and the problems they encountered. One of the features they asked us was the ability to save a search query and reuse searches stated before, similar to the functionality provided by PubMed. That's a nice feature request we're currently implementing. Furthermore, it was requested that free text searches are also highlighted in the text. Another nice feature which really could improve our system, but we haven't thought about it before. Additionally, they found bugs in our systems we weren't aware of. For example, the query builder I just showed you allows one to create Boolean queries. It allows to state a not query, but there was an issue with that. And thanks to the track here, we were able to detect the bug and fix it. Obviously, the text mining component produces false positives and false negatives. We try to fix them, and with our feedback mode, we can gather the feedback from the user to improve our system. Other questions asked to the user were numeric, and we can conduct averages means from that. Overall, the users were quite satisfied with our system. They would recommend our system to further users and found the system quite usable and easy to use. However, we only had 8 participants. So it's not really clear whether that was luck, that the users were satisfied with our features or not. However, some of our users were really happy with the system, where others were not. But we would like to thank all of those who provided feedback to us. And if you test our system now, you can provide feedback to us on one side through the feedback mode, which I showed you, or via the blue box on the right side of the screen. The feedback will be sent to us and we can incorporate the feedback you gave us. Thank you for your feedback. Additionally, I would like to thank the organizers of the track for the great track and the opportunity to take part in it. I would like to also thank my supervisor, Juliane Fluck, my colleagues Roman Baum, Lisa Langnickel, and all alpha and beta testers integrate or cooperated within the system development. Also, I would like to thank the partners in the Task Force COVID-19 project, which was led by Iris Pigiot. With that, I would like to conclude my talk and thank you for your attention.
Thank you very much for your excellent talk and your great work. We are probably pretty tight on time. I don't see any questions right now in the chat, but I will ask one quick question before we move on to the next speaker. I was curious, you showed a capability of generating or getting other phrases or synonyms for your searches. Is that something that could be exported? I mean, that kind of capability might be very useful to people.
Yes, this can be exported. This function of this synonym expansion is provided by our previous system, which is, or not previous system, by our semantic lookup system, which is based on the ontology lookup system. And there's an API available which allows that exportation or this export functionality. So it is there. There's also an API for it, but it's not part of the previous system.
Great, thank you. All right, we are going to move to our next speaker. And that will be Ilya Tiagin, who's going to talk about the Agatha system.
Yeah, hello, everyone. Yeah, I'll just share my screen. A second. Yeah, can you see my slides?
Yes.
Yeah, okay, great. So let's start. Welcome, everyone. My name is Ilya Tiagin, and I'm glad to present our recent work at Biocreative 7 Workshop, Track 4. So let's start. And we're going to talk about interpretive visualization of scientific hypothesis and literature-based discovery. So our main motivation was that the number of scientific publications grows fast, and this is one of the main challenges modern researchers are struggling with. And different machine learning algorithms and AI systems try to automatically connect previously disconnected concepts and formulate novel scientific hypotheses to accelerate scientific discovery. And some modern systems show promising numbers and inference tasks, but their interpretability is still an open challenge. So there is a need for a human-friendly way to understand the results produced by such systems. And in this project, we present an approach of interpretable visualization of scientific hypotheses, which is based on the idea of semantic concept interconnectivity, network-based, and topic modeling methods. So we start our pipeline with building a large heterogeneous graph, which is used as a data source for both inference and visualization purposes. For that, we perform text preprocessing stage, which included splitting all Medline and Core 19 dataset abstracts into sentences and extracting different semantic structures from the sentences, which are presented on the diagram. So we have the following node types in our graph. These are sentences, lemmas, engrams, entities, predicates. These are subject, verb, object triples, and the mesh and UMLS terms. So to obtain a vector representation of this network, we perform a graph embedding stage with PyTorch big graph embedding system, which puts every node in a unified vector space of dimensionality 512, such that similar nodes are clustered together. And you can see it on the picture. Then to generate a visualization relevant to the input query, the first step is to obtain the subset of nodes in Agatha semantic graph, which would be relevant to both source and target terms. For that, we first locate source and target terms in our graph, and then we find the shortest path between them. So it is shown in red. Then we extract a cloud of textual information nodes of a sentence type around the shortest path, which serve as an input for topic modeling. Another piece of information collected from the graph is the sentence neighbors or semantic structures contained in the extracted sentences, forming a vocabulary during the visualization part. So the next stage is performed when the interactive session starts. It begins with topic modeling. And in this project, we use the LDA model, which stands for latent diversity allocation. And this is a statistical approach to find a set of implicit and fuzzy clusters in the provided textual data set. And we use it to represent the input corpus as a user parameterized set of topics that cluster the documents in an explainable way, extracting topics with the most probable vocabulary terms. As you can see on the left here. So this is an example where from a document extracted topics about DNA, genes, about just life and organisms, brain, neurons, and so on. So the topical network construction utilizes key nearest neighbors algorithm, which takes a set of vectors and input and produces a network of closest key neighbors of these network of these vectors. And in order to obtain the vectors for each topic, we represent them as centroids of keywords they contain. We can see that each topic contains keywords and probabilities associated with them. And then we add source and target terms to this set of vectors, and then we run KNN network construction algorithm. And the main goal of building the topical network is to be able to connect source and target terms through intermediate topics using the shortest path strategy. And a shortest path would represent a hypothesis. So it is a suggested set of topics appearing between the provided terms of interest. And now we describe the deployed Agatha end-to-end pipeline, which is made of multiple building blocks that contains 3 important components. So the first component is a computational server, which runs all computationally expensive tasks. And this server contains an Agatha instance, and it is used to run visualization preprocessing stage and generate large-scale hypothesis ranking on demand, which we provided to domain experts. Then the next part of the pipeline is a query submission form, which is hosted on Google servers, so it's just a Google form. And the last component of the pipeline is a visualization web server, where the web interface is run. It is used only for visualization and exploration purposes and for reconstruction of the topical network on demand. So yeah, now let's get a short system demo. I'll stop sharing here and I'll share my window with where we have the visualization itself. So yeah, so this is the visualization itself, and this is our system. This is how it looks like. And this is an example of a predicted potential connection between COVID-19 and oxytocin. The model itself only has access to knowledge published prior to November 2020. And first of all, on the top panel, you can see the score. It's 0.95 up to 1, which was obtained with Agatha predicted transformer model. And the central pane is the hypothesis space, which contains the topical network. So its layout is not random because topics are placed according to their positions in the latent space. So we can expect that all the topics related to COVID-19 are put somewhere close to it. And the same thing holds for all other topics. So for example, this is COVID-19, and this is topic 6. And if we click on topic 6, we can see that it contains terms related to COVID-19. So shortest path in detail, so this is this pane. It shows how the transition between source and target terms is performed through intermediate topics. So topics lower in chain have more in common with the source term, which is COVID-19. And then we have topics higher in chain, they have more in common with the target term. So our target term is oxytocin, and we can see that these terms are more related to oxytocin. And then we have an embedding pane. It displays how concepts from topics from the selected shortest path are arranged in the latent space. So you can see that topics related to COVID-19, so these are terms related to COVID-19, like COVID-19 patients, coronavirus disease, they are clustered together and they are pretty far from everything else. So this is cluster of COVID-19 related terms, and these are all other terms related to maybe probably other topics. So pick a topic menu allows you to pick any topic you find interesting and construct the shortest path through it. So we can just click on any topic here, and yeah, and these are description of the topics, and we can just find maybe an interesting topic, and we can construct a shortest path through it in this topical space. Yeah, and it is useful because the shortest path found by default is not always the most representative for the hypothesis. And the menu on the right, it contains all adjustable parameters, which include setting key and end parameter, like this one. Then we have LD hyperparameters here, distributional and bias. And this bias parameter, it allows to shift the model focus towards the terms of a preferred semantic type. So in here, we have preferred semantic types for this specific query. We have amino acids, antibiotics, chemicals, diseases, or syndrome. These are typically semantic types which biologists prefer to have in these kind of hypotheses. So I'll stop here, and then I continue talking about the presentation. So yeah. So the lessons we learned based on domain experts' feedback is that topic modeling is actually hard because some responders found results interpretation somewhat challenging due to a specific topic modeling approach in general. And that's why we have topic models actually can be reconstructed on demand. Then we found that feedback is crucial for interface design, and introduction of clickable PubMed links or built-in hints for parameter tuning could help domain experts get better user experience. And the last one we found is that sentence granularity may be better for deep learning inference, but not always for human interpretability, because the sentence is a standard information unit for many deep learning language representation models like BERT. But for successful domain expert interpretation, more contextual information may be required. For example, we could use full text abstracts. So yeah, and let's recap. So the proposed approach produces network-based context-rich visualizations of hypothesis pattern. These hypotheses, these are potential term-term connections. And it is based on the idea of concepts interconnectivity, topic modeling, and latent representations. It also incorporates adjustable parameters and dynamic topical network reconstruction. So yeah, if you have any questions, feel free to contact us or ask them right now. Thank you.
Thank you, Ilya. That was very nice work. We have time for maybe a quick question. Here is a question. So from Cici, what have you learned from the users in this task?
Well, we actually learned from users that was specifically related to lessons learned, because we found that topic modeling is actually, users may need more background to actually construct topic models which make sense, and how different parameters, how to interact with each other, because these adjustable parameters like alpha and beta they influence directly how topic models, what exactly they extract and what they should focus on. And we also found that our interface, it was not perfect. We tried to introduce some changes, like we added some functionality during the track itself. So for example, we added this additional saving functionality, and we there are still a lot of things to do to improve the system, but yeah, we are looking forward to maybe some other feedback. But yeah, but this was very helpful. And yeah, we're going to experiment a lot in the future.
Great. There was just, I think, a follow-up comment saying documentation and videos for non-experts are needed. And
oh, yeah, we house documentation like Wiki on our GitHub. And we try to put as much as possible, but again, we don't have that many non-domain experts to actually get everything they could need to be documented. Because we tried our best, but most of us, we have a computer science background, and yeah, we don't really work on the interpretability itself. We just try to make it kind of as we see it. But yeah, that's a very good feedback here. Thank you.
Okay, thank you very much. I'm going to stop the discussion here because we're going to run out of time, but there are more comments in the chat. So we will move on to our next speaker, who is Ben Giori, who's going to talk about the EMMA system.
Hi, everyone. Can you see my slides?
Yes.
Great. So my name is Ben Giori. I work at Harvard Medical School, and I'm going to present about a self-updating causal model of COVID-19 built from the scientific literature. So we built this model as part of a framework called EMMA, the ecosystem of machine-maintained models with automated analysis. And the goal is to build a system that can generate hypotheses automatically from COVID-19 literature in real time. The first step of this process is to extract knowledge from publications as soon as they appear, then assemble this knowledge into an existing model that continues to grow. So align the knowledge with align new knowledge with existing knowledge in a way that we can figure out how it can be extended. Run relevant analysis on this causal model to find explanations for experimental observations, and then notify users about meaningful new results with respect to this analysis. The system also allows users to register scientific questions on which they can receive notifications whenever a new hypothesis based on new readings from the literature are constructed. And so specifically for the COVID-19 model, the main input for the text mining is the CORD19 corpus. In addition to that, we also take PubMed and bioRxiv medRxiv input. However, we actually found that CORD19 with some delay actually encompasses almost everything from these other sources as well. So it actually serves as a convenient single source of input. Our knowledge assembly system, which is called INDRA, is integrated with about a dozen different bio-NLP systems that were built partly by other groups, partly with our involvement extended over the years. And there are 4 systems currently that are run on every piece of new text content daily. And so the output of these 4 text mining systems are combined with structured sources, including VirhostNet, DrugBank, the CTD database, and some other sources to be assembled into a single coherent knowledge base where names and identifiers and relationships are standardized and combined whenever they are in a matching relationship. So this constitutes the daily updated COVID-19 model. And then with this model, users can interact through queries and notifications. And the model is also applied automatically to explain drug virus effect data. This graph shows how the model has grown over time as new statements are added from new publications. On the right, you can see that there's quite a diversity of entity types captured in this model, a very large number of human proteins, small molecules, non-human proteins, and higher level concepts like diseases and biological processes. And of course, there isn't an equal amount of information about each of these. Certain genes will be much more frequently mentioned than others, but the overall number is very high. And in the bottom, you can see one example of how in several places on the EMMA website, you can browse and interact with such statements. The statement itself, in this case, is dexamethasone inhibits IL-6. It has 406 pieces of evidence supporting it. And you can see example sentences from which this statement was extracted with entities highlighted and the built-in curation interface exposed where you can submit correct or incorrect curations. You can also link out to the source publication. So in terms of putting this model to use, so this isn't simply a knowledge base built from text mining. It actually, this knowledge is actually also compiled into a model that can be used to explain observations. And we obtained observations to explain from two sources. One is we annotated preprints and papers describing in vitro data about drug effects on SARS-CoV-2. And we also ingested relationships curated as part of the MITRE Therapeutics information browser about drug-virus relationships, such as the fact that lopinavir inhibits SARS-CoV-2, and then apply our model to try to find mechanistic hypotheses explaining these observations. And this is one example where, for a relationship like procilaridin inhibits SARS-CoV-2, we find a hypothesized mechanism by which that observation can be explained. And each link on this path is supported by evidence that can be linked to the primary literature. When users interact with the model through queries, they can register their questions, such as what are small molecules that directly or indirectly inhibit COVID-19, and get email updates that link to pages like the part highlighted here, where you see the paths that result in inhibiting COVID-19, along with statements supporting them linked to the literature. We also have a built-in human-machine dialogue for this model, where you can ask questions from a machine assistant, and these questions are answered based on the content of the COVID-19 model. And I'd like to thank the team who worked on this system and our funding from DARPA. I also wanted to put this slide on about the user feedback. We are really thankful to all the users who tested our system and provided feedback. We got a lot of positive feedback, as well as several very, very good and constructive ideas on how to improve the system, including making the load times faster for each of the pages, adding auto-completion to some parts of the forms where users have to fill in queries, certain types of mechanisms and entities that were missing from the results. So we got a long list of very useful things that we can now go back and fix. And we are already actually in the process of making some of these improvements. And for the last couple of minutes, I want to switch over to the website itself. So website is available at emma.indra.bio. You can see that Emma is actually general to many different applications, not just COVID-19, and the COVID-19 model is one of the models that are available. When you go to the COVID-19 model page, you can see basic details about the structure of the model. You can see, for instance, that it was updated, last updated yesterday. You can see overall statistics about the content of the model, the types of statements, the most frequently mentioned entities, the sources of knowledge. Many of these sources are text mining systems. Some of them are structured sources like CTD. And you can actually see this graph of how the model has grown over time with new statements extracted from new literature. And you can actually see this very large set of new statements that were added with the last update. You can see a pencil next to one of these, which means that this was curated as having been incorrect. And you can actually go through and curate the new statements each day for correctness. The tests tab allows you to access these drug-virus relationships and how the model could explain these. You can see the percentage of these, so quote unquote, tests that passed each day, currently at 82% for this test corpus that was again extracted from drug virus screening hits from the literature. The MITRE corpus that I also mentioned, which contains more than 3,000 such relationships, can also be loaded here. And as you scroll down, you can see that all of these relationships that were observed experimentally could actually be explained by the model. And you can click through and actually look at some of these explanations. So if I click on this green check mark, it will actually pull up what the specific explanation was behind this observation. In this case, the hypothesis is that this drug MK2206 inhibits SARS-CoV-2 replication through PI3K. And clicking yet through to the underlying statement, what you can see is that there's literature evidence for this drug inhibiting PI3K. Takes maybe a couple more seconds to load that. So you can see the specific sentences and publications supporting it and have the opportunity to curate for correctness or incorrectness. The last thing I wanted to show is let me just try to get there, is the chat feature. So I'll actually start a new chat session quickly. You can start a chat with this model, say hi, and then ask what is cathepsin L to get a description of an entity, what inhibits it. This now comes from the model itself. So these are things that are known to inhibit cathepsin L based on the model. You can again follow up by asking, do any of those inhibit IMPERS2, which is another important entry point for the virus in human cells, and you get a list of things that inhibit it. You can ask which of those are small molecules. We got chemostat and eloxystatin, both of which happen to be under clinical trial currently for COVID-19. And from each of these, the last thing I'm going to show is that you can actually link to the statements with their respective evidences from each of these dialogue system answers. Takes a little while to load. Yeah, so that's it. And I'm happy to answer any questions.
All right, thank you very much, Ben. That's a very rich and impressive system. I am looking for questions in the chat. Meanwhile, I will ask you one quick question, although we are kind of tight on time. My question is, to what extent has the curation interface been used, and how do you control for quality of the curation?
So I haven't looked this up before the talk, but I think we have on the order of thousands of curations, although many of those come from our team internally, but there are maybe about a dozen users from outside our team who have contributed curations. I'm never concerned about the quality of the curations. You know, the order of magnitude of potential sources of error outside human curators is much larger, and so whenever human curators come in and curate some things, it's typically a net positive. But of course, given that the way these are stored, we can always control for have multiple curators curated this sentence, or evidence is supporting a statement, and so on. So there's always space to be more strict about these curations. Currently, I didn't mention that explicitly, but when things are curated as incorrect, they get excluded from the next update of the model and get excluded from potential explanations from the model.
Okay, great, thank you. I think we are going to move on, although we are having some issues. Let's see. I can see that. Have we gotten Jinfeng Zhang online or not?
Yes, I'm online. Can you hear me?
Ah, okay, great.
Sorry,
okay.
My computer crashed at a very bad time, and I couldn't restart it. I'm using my student Xin's computer right now, and I had some trouble, logging in. Okay.
All right, over to you.
All right, so let me share my screen. I will, let me see. Okay, this is a web browser. Can you see my screen?
We can see your screen, yes.
Okay, well, first, thank you very much for organizers of Creative track 4. We have learned a lot from this track. I'm sorry for my computer crashing at a very wrong time. Our system is called BioKDE, short for Biomedical Knowledge Discovery Engine. And it has mainly two components. The first one is the search engine. You can search for all the articles in PubMed by selecting these scientific articles, or you can select patent to search all the US patents. Let's try it. If we search say COVID-19 risk factors. The interface is very similar to PubMed, so it should be familiar to many of you. And you can sort these articles using relevance, publication date, or citation. So this citation is our unique feature. You can click article, read its abstract, and then there are links to full text articles from PubMed Central if it's available. And also you can find out references and also this set it by function, which paper cited this particular article. Yeah, let me, where is where is the other one? Yeah, I have to somehow get used to using this. Okay. Oh, here. All right. Yeah, sorry, I have to kind of get used to this laptop. So one important use for function here is you can click knowledge graph button, and if we click that, you can see a knowledge graph displayed. For by default, it's the top 20 articles here, and you can save this knowledge graph using this save as, and it will generate a unique URL. You can share that with other people, and you can change number of articles displayed using this function here, edit selected articles. And for example, we can select the top 50, and then you select all, and then okay, again, I need to move this down. Okay, where else? Yeah, you can see now we have a top 50 articles selected, and you can choose certain entity type to be selected, or you can remove some. Say if you don't want to cell lines, you can remove these, and you can also select a different kind of relationship. For example, you only want to see, say, disease and gene relationships, and then that will only give you disease and gene relationships. Yeah. Oh, by the way, to generate a knowledge graph, we need to tag these annotated names. For example, diseases, genes, species, chemicals, etc. And also, we need to get edits as their relationships. For now, we are using pub-data results, and for the edges, we basically just use per occurrence. But we are going to implement the methodology we developed and then also developed by some other teams in Biocreative to update these functions. For example, we'll use a method we developed in track 2 to tag the chemical compound, and also try to use that method for tagging other names. And if you click edge, and you will see these sentences mentioning that particular relationship from PubMed articles. And here, you can also edit this knowledge graph. Yeah, by selecting, you can delete node edges. For example, here, if you want to delete this node, and then if you made a mistake, you can go back. And you can also edit add node edges, or editing them. Let's say if we add a edge. To add an edge, you can specify source nodes and target nodes, and you can just type let's say COVID, and then yes, output complete. Okay, yeah, we need to change this. Okay. Oops. Oh, what happened? Yeah. And then let's say this co-infection, if you want to add edge between COVID-19 and co-infection. Oh. And you can do that. You see there's an edge added. And you can also edit them, adding some more information. Yeah, that's somewhere over there, edit edge. And so we made a knowledge graph manually created. On the first page is a COVID-19 risk factor knowledge graph. So we read a lot of papers and then manually edit a lot of nodes and edges. Here we separated COVID related phenotype into three types: COVID general COVID-19, and then deaths from COVID-19, and then severe COVID-19. Basically, those patients who are admitted into hospitals. And then you can see there are actually a lot of risk factors fall into different categories. We added some other categories like demographics and some just other type of risk factors. And then you can click a particular edge, and again you can find articles and then the sentences mentioning the corresponding relationships. And so I guess that's pretty much demonstrate. And then we learned quite a lot from the feedback from the track 4, for example. And when actually multiple users mentioned this number of selected articles to show, it's hard to modify. In fact, we have the function here, but exactly we kind of hide it here. But that's actually a very useful features. We'll modify that. And also people mentioned there are name tagging errors, and we noticed that also. And that's actually why we spent a lot of time really work on track 2 in this Biocreative challenge. And we did well on that, so we'll implement our methods to improve the name tagging accuracy. And also user suggested that we add some kind of filtering for the edges. Indeed, if you look at the early knowledge graph, it's really a lot of edges because we're using concurrence. So we'll certainly implement these relationship extraction methods, and then use these to help user to filter out unrelated relationship. So there are a lot of work to be done. And we hope users will use this and then generate these manually created knowledge graph and share with other researchers. And to kind of, we want to make it community-wide efforts to convert unstructured information from literature into structured form. And we can use, we are planning to implement other functions for using this knowledge graph. For example, we can perform highly accurate and specific knowledge retrieval using structured information in this knowledge graph. And also we're trying to implement the deep learning based link prediction method to predict new relationships for knowledge discovery. I guess that's pretty much. Thank you very much. Any questions?
Thank you very much for a very interesting talk. There are 2 questions in the chat, which I will read. One is, what front-end library do you use to show the nodes of the knowledge graph?
We use Cytoscape.
Cytoscape, okay. The next question, is there a way to know that an edge has many publications supporting it versus just one? I see all edges with the same width.
Yes. So that's good suggestion. Right now, we don't have that function. we can definitely put it on our to-do list, basically maybe showing different ways if it has many publications to support versus you're just one. That's good suggestion, but we don't have it right now.
Okay, thank you. And I had one question, which you sort of mentioned in passing. Are you thinking about adding any kind of curation feature in case people want to correct, mistakes?
Yes. We have it. For example, if we want to, we have these editing functions, you want to delete node edges, you can delete edge, you can delete node. If we want to edit, let's say I want to edit this edge, and actually, I don't know how to do a right click. Can we do right click? Double tap, right click. So I don't know how to use this mouse, but we do have a should I click the node? No. We can edit these if you
and the follow-up
here.
question,
I just figured out. See, you can click edit, and then you can add say a new parameter article supporting that, and then adding the different adding sentences from that. You can edit node, you can edit edges, remove them.
Is that just on your local copy for your personal use, or is that going to be seen by the next user of the system?
Oh, that's a good question. So in fact, managing this user input is definitely not trivial. We are implementing some kind of a layered approach. If a user just modify for his or her own purpose, then they can save a copy and they can keep that copy, and then they can share with other people. But we're thinking that maybe we can have some mechanism that to verify the people's input, and then somehow if really high quality ones, we can kind of merge with our central database and then allow other people to be able to use that curated information. But this quality checking is actually not trivial. I welcome people's suggestion and then collaboration to work on this.
Thank you very much. We're going to move to the next speaker, who is Tanya Corvus, talking about the COVID-19 therapeutic information browser.
Thank you.
All right, great. Hi, everyone. Hi, I'm Tanya. For my talk, I'm going to go ahead and play my video. Let's see, here it is. Please go ahead and let me know if you can hear this. Hi, I'm Tanya Corvus from MITRE. I'm presenting a tool to help with the large volume of COVID-19 research. It's called the COVID-19 Therapeutic Information Browser, or COVID-TIB for short. We built COVID-TIB to make it easy to find and track information about potential therapeutics and vaccines. COVID-TIB is a resource for finding publications and clinical trials about viruses and therapeutics. It includes candidate drugs for SARS-CoV-2 and 12 other viruses. It also includes information about viral vaccine research. And to facilitate tracking the status of research, in COVID-TIB, results are sorted by research stage, such as clinical study, case study, or in silico. Now, to capture this information at scale, we applied NLP. There are challenges in building an NLP pipeline during a pandemic. First, it must be built very quickly because it's needed right away. We had no prior curated data available for training an algorithm. And the system needed to be adaptable for a rapidly evolving research landscape. Here's our NLP approach. First, we query for viruses and retrieve documents. Our sources are PubMed, Cord19 for preprints, and clinicaltrials.gov. Then we use a two-step rule-based NLP approach. First, we identify entities and keywords within sentences. And for this, we modified Reach software from the University of Arizona, We use custom dictionaries for viruses and drugs. There are 12,000 different drugs in our dictionary, most with drug bank IDs. We also use custom keyword lists for research stages. Then we assemble information across sentences and classify documents. For this, we use R scripts with rules and threshold of evidence for classifying documents as about a particular virus and drug and in a given research stage. Now we iteratively and incrementally improve the NLP results over time. And for precision, we did this through curation. In the early stages, we used a curation platform that we developed to identify errors and then make improvements in rules. For recall, we made improvements by comparing to clinicaltrials.gov and lit COVID results. To date, we've processed more than 270,000 documents. We've identified 26,000 paper abstracts and clinical trial summaries about SARS-CoV-2 and named therapeutics. And we've identified documents about nearly 3,000 different therapeutics. We've also incorporated full text search and information retrieval capabilities using two tools from the University of Wisconsin-Madison. These are XDD, which is a searchable digital library with full text publication content provided by open access and partner publishers, and Cosmos, which is a machine learning-based platform designed to serve as a technical assistant for extracting information from documents. Now I'll give you a demo of COVIDtip. This is the COVIDtip homepage with a description. On the left is a navigation menu. There's a therapeutics page and a vaccine research page. Let's click on therapeutics. Here we see a table with drugs going down the side, viruses across the top, and research stages beneath that. And the numbers in this table indicate the number of documents about a particular virus, drug, in a particular research stage. So we have 372 documents about remdesivir and SARS-CoV-2 that are clinical studies. We can expand the list of drugs or scroll over to see additional drugs, and we can also scroll over to see additional viruses. Let's say we want to see the drugs that have been published about recently in silico studies. We can go over here to the filters. We can go ahead and select past 2 weeks, and then we can go ahead and sort by in silico and see those drugs. Now let's say we want to look for a particular drug. We can go ahead and type the name in here. Let's look at famotidine, and let's select clinical studies. Then if we scroll down, we get a table that shows the documents here with link outs. And we can also download this list of documents as a CSV file here. We can also go ahead and link out to Cosmos for figures and tables about SARS-CoV-2 and famotidine from papers. Here on the Cosmos site, we see related terms and we see figures and tables from papers. Say we want to see drugs for long COVID. We can go ahead and type the long COVID in as well as some synonyms. Then go ahead and search for these, and what it's doing is searching for these terms in the full text of a subset of the papers. And here we see the drugs with papers with these terms in it. We can go ahead and click on the one for glucocorticoids. And then if we go ahead and scroll down to the bottom in our list, we now have the option to search snippets. So we can go ahead and click on this, and what it does is it shows us the bits of sentences from the paper with our search terms in it. There are additional files for download on the menu, including data, information about our methods, and an analysis of COVID drug research trends using this data. In the biocreative evaluation, there were 12 users. They commented that it was easy to use, fast, and well organized. They suggested improvements in adding reset buttons, in improving ability to find drug names, and an increasing amount of data for download. And their comments also highlighted that comprehensiveness is particularly important in a tool like this. And this is an outstanding challenge for entities like drugs, which have rapidly evolving namespaces. COVIDtip has multiple potential uses. The biocreative users suggested that it could be useful for knowing the state of research, for systematic reviews, and for clinical guideline development. To date, researchers have used COVIDtip to gather information for drug research studies, to identify papers for a curation effort, and to identify test cases for the ML models that you saw earlier. COVIDtip also has potential applications beyond COVID-19. It could be adapted to track research on therapeutics for other viruses and diseases, And more broadly, the approach could be applied to research in other domains that also have a large and growing literature. With that, I'd like to acknowledge my colleagues who contributed to this work, who are listed here, and thank our funding sources. For additional information, please see our website. Thanks.
Thank you, Tanya.
All right, thank you. I'm happy to take questions.
Yes, well, while we're waiting to see if there are other questions, I would be interested in your comments on what it might take to adapt this framework to a different topic. I mean, we've seen frameworks that are general that were then specifically adapted to COVID, but this might be a case of going the other direction.
Mm-hmm. Right. Yeah, and I think, as I mentioned, it's readily adaptable to other viruses. And I think to adapt it to other topics, it's sort of basically sort of a matter of figuring out what the categories are that are of interest, and then sort of building out the NLP for that. And I think one of the areas of interest would be, you could incorporate different methods of NLP categorization into a dashboard like this would be an interesting way to go.
Yeah, I was thinking, listening to the talks on the topic clustering, for example, it might be interesting to try some of those out in this context.
Yeah.
Here's a question from Cece. I saw you use Cosmos. Do you extract any information from tables or figures there?
We don't. Cosmos displays, though, basically identifies the ones and displays them, but we don't extract information from those. No.
Okay. From Andrew, was it difficult to handle the compound synonyms?
Compound synonyms. And could you? I'm not exactly sure what's meant by compound synonyms. I know we have compound drugs. We have combinations of drugs that we treat as entities unto themselves as well as individual drugs. If that's what you mean.
I know that there was an issue with naming and referencing compounds in terms of the pointing back to drug bank. So yeah, compounds are tricky. Right, Andrew followed up saying usually the same drug or active compounds have multiple nomenclatures. Yeah,
right. Yeah, we have a number of synonyms. Yes, and yes, that is a big challenge. Is maintain that list of synonyms, because this space, there are new drugs all the time and they get renamed. We see that every week. Yeah, keeping that up to date is a challenge.
Okay, and one last question. Were there some challenges on the computing performance in terms of the queries and process data size with respect to the user queries?
I don't think so. I think we didn't. This runs pretty quickly, the processing. So yeah, I don't think we had real challenges there.
All right, thank you very much.
Thank you.
And we will now go to our postponed talk by Amy Alex on topics. So Amy, glad you could make it, and
Hi.
Thank you for your mad dash to your office.
Yeah, sorry. Great time for them to be doing construction in the neighborhood, right? Yeah, can you see my slides?
Yes.
Great. Trying to get these Zoom windows out of the way here. Whoops. Okay. Hi, everyone. My name is Amy Olex. I am the senior scientist at Virginia Commonwealth University's CTSA funded Wright Center for Clinical and Translational Research. And today I'm going to be telling you about our tool Topics. Topics is a natural language processing tool designed to help non-technical users explore topics in a set of texts. And the best part is no programming or NLP knowledge is needed. So how does Topics work? Topics is an unsupervised exploratory tool that operates on sentences. The first step in the topics pipeline is to clean the input corpus and normalize it to remove variability in the text. This includes removing and expanding contractions, adding parts of speech, doing stop word removal, and converting all characters to lowercase. The second step in the topics pipeline is sentence representation. To do this, Topics takes the input corpus and uses it to create a term frequency inverse document frequency matrix, or TF-IDF matrix. This matrix is then used in two ways. The first way is to identify the most informative phrase of the sentence. And then the second way is to utilize that matrix to convert that phrase into a numerical vector representation that can be used in the next step. With Topics, the background corpus by default is the input corpus, but you can also customize that to add additional documents or use an entirely different corpus to create the TF-IDF matrix. It's especially Topics assumes that each sentence has one topic only, so it only gets one numerical representation. The next step in the Topics pipeline is sentence clustering. So sentences that have similar numerical representations are assumed to also have similar semantics. So these sentences are then clustered together, and these clusters of sentences are then run through a classic LDA topic analysis to identify keywords and topics present in each of those clusters. These are then visualized as a scatter plot that is built with the UMAP algorithm. So as part of the BioCreative Challenge, we used COVID-19 tweets during the year 2020 as an example use case. We analyzed a subset of tweets from each month in 2020, and here I'm showing you two of them. In March, Topics was able to find topics about helping to stop the spread, new cases and death updates, how the media responded to Trump, as well as some COVID testing and tweets on staying home safe. In December, we can see these topics shift quite a bit, including discussion on new UK variants, Biden receiving the Pfizer vaccine, and three clusters that are very close together on the COVID relief bill. We can also see that there's a common topic, and this topic actually appeared in every month that we analyze on new cases and the death toll. So this is from March and December. So for our live demo, I'm going to go ahead and show you the results from the month of May. In the interest of time, I have already preloaded the data. In this first example, all I did was hit upload documents to cluster and uploaded all of our tweets as individual text files, and then hit run topics using all default settings. These are the results that you get. So this is the scatter plot that is built using UMAP. Each dot represents an individual sentence. And the closer the dots are together, the more similar they are semantically. So you can scroll over the dots and you can see that the information appears up on the right-hand side of the screen. Specifically, the cluster topic that was identified for this particular cluster, the top 10 words are shown. We have the raw original tweet or sentence. We have the phrase that was pulled out of that sentence for clustering, as well as the sentence label and the cluster number. So as you can see, some of these clusters, if you look at the cluster topic here, the top keywords include COVID-19, include coronavirus, COVID-19 pandemic. For this particular corpus, these were all tweets about COVID-19, so that's not particularly helpful for our analysis. We don't need to cluster topics on those words. And to get an even clearer view of how dominating these terms are, you can use the word cloud visualization for each individual cluster. So here's cluster 1, and we can see COVID-19 dominates that cluster. And then if we go down to cluster 18, coronavirus dominates this cluster. So we don't really, those words again aren't super helpful. So the second run I did was using the same documents, and I uploaded a custom stop words file. Stop words are those words or terms that are not interesting to your particular analysis. In this case, it's COVID-19. I also changed the vectorization method from the default SVD to using the raw TF-IDF, which I find tends to work better for tweets. And so here's our new UMAP plot with our new clusters. And so we can see we have a bunch of smaller clusters. This one in particular is on then President Trump's visit to the Ford plant. And then we have some clusters on the death toll, for example, confirmed cases and death here. And again, we can see in the word cloud how we no longer have COVID-19 or coronavirus as a dominating word. Instead, we have more informative terms. So that stop word functionality is probably one of the most useful features that I've found when I'm doing analyses with topics. Okay, so as part of the BioCreative challenge, there were several other use cases suggested by users in addition to the current use cases. So currently, Topics is being used to analyze reflective medical writings from students to identify challenges that they're experiencing in the medical curriculum here at VCU. We've done COVID-19 discharge summaries. That's an internal use. And then we've also analyzed government COVID-19 communications from South Korea to identify mitigation strategies and how they changed over the course of the pandemic, in addition to the tweets we just saw. Other use cases by the BioCreative 7 users include analyzing PubMed abstracts, grant summaries, publications, interview transcripts, and open-ended survey blog responses. So our user feedback, we got positive and negative feedback. A lot of it, they were either like all 4 topics or it wasn't really working for them. So positive feedback, most users said it was easy to use interface with intuitive navigation. It was relatively quick in returning results, although there's an asterisk by that one. It's good at identifying trends in the data and useful for getting quick grasps of topics that are present in your corpus. Aspects that could use improvement to better the experience of the users include bettering the error handling, especially with data imports. One of our features was stated to import a CSV file when really that was actually a pipe delimited file. So being clearer on that and also providing more options for input formats. It also needs more on-site information about those customizable parameters. All of that is extensively listed in the user documentation, but users found that it would be helpful to actually have it on site. And then again, the running times, some users that input larger or corpora or documents that were larger than a paragraph experience longer run times that weren't really useful for their day-to-day activities. So the overall impression of topics scored an average of a 3.3 out of 5. And when asked if they would recommend COVID topics for COVID research, we scored an average of a 6 out of 10. So based off of the feedback, which was really helpful in determining what aspects of topics were good and what needed improvement, short-term improvements that we're already starting to make, including adding more on-site documentation, clarifying the data formats, and supporting native Excel files, since a lot of users are experienced with getting data in the Excel format, and including the document or PubMed ID in the output. That is included in one of the outputs, but not in all of them. Longer term improvements include investigating algorithm parallelization for those bigger documents or bigger jobs, or a job submission type framework where it will email you when it completes. And to add on-screen options for stop words. Right now it's just uploading a text file, but some users suggested to add a text box in there so they could dynamically add in stop words and rerun the analysis in the interface without uploading other documents. And also implementing different levels of clustering like paragraphs or documents. Right now, topics only works on sentences, but there are use cases where summarizing a whole paragraph or a whole document might be interesting for users. So finally, I'd like to thank the many people that have gone into the development of topics, specifically the Wright Center Informatics team led by Dr. Tomascow. Evan was involved in helping out build out the back end of topics, and Peter did the web interface. And Shri helped out with the use cases as well as with some of the back end functionality. The NLP of ECU lab and from the computer science department led by Dr. Bridget McKinnon, and 3 of her students who actually helped build the first prototype of topics that we were able to work off of. And our collaborators, specifically Dr. Diaz-Granados, Santon, Kim, and Thomas Newman, who are all involved in the initial use cases for using topics and giving us feedback about what was useful and not. And finally, I'd like to thank the BioCreative team for organizing this challenge. It was a fun experience and really useful. So thank you. If anyone has any questions, you can feel free to email me or ask them now.
Thank you very much, Amy. And I appreciate your being able to actually get to a place where you could do this. There are a bunch of comments. In the interest of time, I will refer you to the chat window, and I think we will now go back to Andrew to wrap up. So Andrew, over to you.
Can you see it?
Yes.
Okay, perfect. Okay, so I'll go quickly to have a summary of the results. And so the evaluation process was pretty straightforward. The only one thing they would require was to provide the extensive documentations in terms of tutorials and instructional videos, because all these systems, have you seen, they're very different in scope and implementation. The users could land on a page on the BioCreative website where they could have an introduction to the system and choose which system to evaluate. And they were following documentation, they were familiarized with the tool, and then were asked to perform independent tasks. At the end of this evaluation step, the users were asked to fill a survey. The survey was divided in 3 parts. In the first one, we were being informed about the tester background. In the second one, the users were providing feedback about their specific experience with the systems. It was a questionnaire with open-ended questions. And in the final section, we were probing the user's takeaway and overall experience. So you can see, I would say that all the systems, the specific features that each system was providing was appreciated. It wasn't really a barrier to the use of the teams or the systems. You can see some of the terms that better describe the systems. And we also try to provide a little bit more sound metrics on the feedback of the users. We employed a system usability scale. You can see here on the top right. And I would say that overall, the feedback was positive. We see that the score dips down a little bit, and this is for the code and reasoning tools, so tools that were a little less intuitive to be used. Also, the overall impression was pretty good, and there was a dip down again in the meta expectations, which probably also depends from the need for more documentation, more features, for instance, search options, more outputs, and in some cases also more performance. Also, the system developers provided their point of view, and the task was positively received. What was really appreciated was the feedback that allowed them to improve the usability of their systems and to implement new features. Although they also lamented the lack of further round of interactions with the users. And another complaint was about the body of the users. They would have appreciated more testers, specifically their end users for which their systems were designed. So concluding, I would say that the task was successful, although there was some request to provide a common task to all the systems, so to have a more formal evaluation of the different system across a single task. Desired to have more metric as a feedback, for instance, in the search speed. And as I mentioned before, to have a larger group of testers, which is actually the most tricky part of this task. And a reminder also for the systems is that documentation is never enough to provide rank results whenever is possible, and to provide the results in downloadable formats and multiple formats. I would just leave with some open questions that I don't know if we're gonna have them to discuss, probably not, but there are any lessons learned. We'll be ready for the next pandemic. We know, for instance, that now we have tools to easily access preprints and other sources. Are these tools sustainable? Are they going to be available in 6 months, in a year? Can the biocreative community do more for the visibility of the system? And do we need to reshape the format of this task in a more competitive task? And I would like to conclude and thank all the organizers of this task, but not only them, all the biocreative organizers. I think it's been a wonderful edition, it's incredibly interesting. And some special thanks to all the participants, all the testers, a special mention for Rose Alfred, that was really instrumental in recruiting the users, and the International Society for Biocuration, and the whole NLP community. Thanks again, and I think I'm gonna stop here.
Thank you, Andrew. And that concludes this session. Sorry, we ran over a little bit, but I turn it over to, I think, Cece now for the general discussion session.
Well, I guess we have to get everyone, all the panelists, I mean, all the organizers here. But let me now at least share my screen, just a minute. And you might see yourself for a moment. Let me see. Wait, because I cannot find the, okay. Can you see the PowerPoint?
Yes.
Okay. So first of all, I just wanted to go over and see if run a quick poll for the people present here very quickly. Can we run the first poll about where people have attended this BioCreative for the first time? Grace, can we run that poll? Can we start that one? If you can quickly click yes or not, whether this is your first time in a BioCreative meeting, that would be awesome. The panelists cannot vote, but we can tell that they participated in BioCreative. Well, we don't know if it's the first time. They can probably tell later. Okay. So we have the results is 75, more or less 74% of our people here have been in some BioCreative. Is the first time, okay, that they are in this workshop. Okay, welcome. So this is an unusual one. The next one, I just wanted to introduce, if it can be made a panelist, please, Chris Tyler Beck, who's going to introduce a new challenge evaluation that is upcoming. And then we're gonna try to go ahead, and there's someone raising the hand. Let me see. Let me see if we can do something about that. All right.
I'm able to speak now, Cecilia?
Yes, go ahead. Sorry, Tyler.
Okay, perfect. I'll just have to share the screen.
Yes, just give me a second. I stop
No
sharing.
problem. All right, can you see it?
Yes.
Yes.
Excellent. Hi, everybody. I'm Tyler Beck. I am a program officer for NCATS, the National Center for Advancing Translational Sciences, part of the NIH. And we have we've been delving into NLP processing a bit in the last few months and have just launched a challenge as of yesterday where we're asking natural language processing, we're actually asking for competitors to build natural language processing systems to go through free text of abstracts from biomedical publications and create both annotations and also assertions between the knowledge assertions between those annotations. So I'm going to go through that a little bit for you here. So this is the process that we envision for the full Litcoin concept that we're working on. And the general idea is that NCATS would like to create a new type of scientific research publication that we will call the Litcoin. The idea behind it is we want to have a way for people to both share data openly in a relatively straightforward way, and also to generate computationally accessible data immediately upon upload of these short publications that we would like to call Litcoins. So the general idea behind it is you would have a researcher who makes an observation in the lab or in their data analysis, something like that. And this might be something that is not a big enough topic to fit into the next big paper that they're working on that they want to submit to Science or Nature. And instead, this could be a small observation, but could be relevant to a lot of researchers. There's also the possibility that people could use this for what so-called negative data, though I hate to use that term, where the data showed the opposite from what their hypothesis was going in. And those things are hard to get published in general. And so the idea is you would write a short publication, probably the size of an abstract, a couple thousand words at most, and you would upload the text of this publication to our Litcoin server that we want to build out. As part of this server, we would have a natural language processing system that would determine the assertions, the knowledge assertions between all of the biomedical concepts in the text. And so, for example, you might have a sentence that says COVID-19 vaccine reduced the incidence of SARS-CoV-2 in certain population. And so you would have an assertion that the NLP would pull out that would say COVID-19 vaccine reduces SARS-CoV-2. That's the idea. So we would then want to have all of these assertions displayed to the researcher directly. And then the researcher could say, yes, that assertion the NLP pulled out is exactly what we were trying to say. Or maybe it's not, and they have to make some tweaks. And that could help us retrain the algorithm in the long term as well. So then after the researcher verifies all the assertions that the NLP pulled out, they would get to download a package that would include the assertions as well as their text, and they would take it over to a publisher's website and upload it and be able to publish directly, including the assertions that came with it. And then the assertions would also be available to the reviewers during the review process. This is all with the hopes that we would be building a large assertions knowledge base from all of these publications that we could then make openly accessible to data scientists. So that all is the big long-term pilot process that we want to build. But first, before we're ready to go into that full process, we want to make sure that the NLP is where we need it to be in order to make this work. And so we have put together a challenge called the Litcoin Natural Language Processing Challenge. So it is available now, right now on challenge.gov. I will be throwing some links into the chat right at the end of my talk here so that you can get there easily. The prize purse for this challenge is $100,000, which we're splitting up into several smaller prizes that I'll show you here in a moment. And I wanted to talk a little bit about the training and test data that you'll have access to if you decide to take part in this challenge. So I want to thank Dr. Cecilia Arihi, first of all, and Dr. Jihong Liu at NCBI for making a corpus of data available to us that they've been working on for a good long time now that includes 600 hand annotated abstracts. And so these abstracts have the annotations of the biomedical concepts, as well as the assertions, the connections between these concepts that have all been hand annotated. And so we're using that for our training and test data for this project. As far as actually running the challenge, we at NCATS have run a few challenges before, but we hadn't run any that were quite this level of technical that's needed, technical ability that's needed for this. And so we turned to the NASA Tournament Lab to help us find a challenge contractor for this. And so the NASA Tournament Lab helps government entities connect with different challenge vendors, and they provide guidance as well on the design and implementation of the challenge. And so they actually put out a call for challenge vendors for this challenge. And of the submissions that we got back, a group called CrowdPlat was chosen. CrowdPlat is a crowdsourcing and freelancing platform that right now, this is their first Tournament Lab contract that they've gotten through the NASA Tournament Lab. And they're in charge of the competition management and the social media outreach. And then they're working with an AI competition platform that I hope some of you are familiar with called BitGrit. That company is based in Tokyo. And they're an AI competition platform that runs all kinds of different competitions. This is a couple of the examples of ones that they've run recently, a prediction algorithm to try to determine what tweets will go viral, a competition for optimizing shipping routes, and a competition to predict breeds of dogs based on the dogs' images alone. So those are the kinds of competitions that they've run recently. So the basic way that this is going to work is that once you sign up for the challenge, you'll be asked to, so you'll have access to the data. You'll be able to download the testing and training data, and you'll be asked to submit the results of your algorithm from the, so you would run your algorithm on the test data and submit the results of that, which includes all of the annotations and the assertions. We then, BitGrit has a custom evaluator that they've built to evaluate the results, compare them to a gold standard, and come out with a score on how well your algorithm has been able to pull out the assertions and annotations. And so then that will immediately update the public leaderboard, where you'll be able to see what score you have in relation to all the other teams that are participating in the challenge. And then the hope is between now and the end of the first phase of the competition, which is December 23rd, you'll have the chance to improve your algorithm and resubmit up to 5 times per day in order to get yourself higher up on the leaderboard. We are asking or running this competition in 2 phases with 2 separate tasks. So the first task is going to be to create the annotations of the concepts in the text. So recognize the biomedical concepts, annotate them, and determine the type of concept that you've recognized. That will be worth 30% of the overall score. Then I believe December 27th is when the second phase starts. We'll ask the teams to create knowledge assertions between these concepts and determine whether those are novel assertions or not. So is this the thing that the researcher is publishing this data for, or is this background information that's from another paper? So those are all, that's all part of the second task, and that's going to be worth 70% of the overall score. At the end of the competition, which is mid-January, we will determine the weighted average between those 2 scores for each team, and we'll be giving up to 7 prizes away. You can see the first prize is $35,000, and all the way down to some runner-up prizes for $5,000 each. So these are the links to all the different places that you can learn more about this challenge. I'm going to also put that into the chat here. So hopefully everybody should be able to see this. It's not coming up. Hold on. I will get that in just a second. But yeah, so I'm happy to take any questions and I will post those in the chat right away.
Sorry, that was not for you. That was for one person who was raising the hand. I'm sorry. I just wanted to know if the person wanted to ask a question or something.
Okay, and here are the links. There we go. So you'll be able to get to the challenge page on NCAS site and also the BitGrit challenge platform to sign up. Thank you.
Okay, thank you, Tyler. So just a quick comment for you. Are you aware of micro publications that are that like Wormbase is using? These have the same spirit as what you're trying to do?
Yeah, so the micro publications, as far as so they do, and the concept there is really great, and we kind of envision hopefully including micro publications in the knowledge base that we're building from this. But we really want this to be accessible to researchers who don't know much about building these types of relationships between concepts, or even about biomedical ontologies. And so we feel like having the natural language processing portion of this pull out these concepts for the researchers and display them to them will help us bring in researchers who generally don't have that background.
Okay. All right. So I think there's a few questions for you or comments that you might want to go ahead and reply to them on the chat box. So I'm going to move to our discussion. Thank you, Tyler. So going back to our screen for the discussion, I guess the floor is open for what are a few things that we can ask. What are directions for future biocreatives? Maybe we can run the second poll, Chris, asking what type of task for the people who can reply to that poll. If you can identify from all the choices, which are the tasks that you are more interested in participating, or you think biocreative can do that, that would be great. Let's give it a few more minutes. No minutes, seconds. Okay. All right, I think it's stable now. We only have 62% participating, but it's okay. Let's look at the results. So we can see that relation extraction, text classification. Can you see the results? And name entity recognition. Those seems to be the most. This is gonna be recorded, so that's good. So the next thing we can think of is what kind of sources, like in terms of text sources, what do people think are, and here I would like, let me close this, and I would like, I need to monitor the chat, so sorry. Can someone help me with this part? So what I wanted to see is how we can bring the people here in the panel, as well, panelists, as well as the participants, to find out, to discuss a little bit about sources of text that you're interested to consider, because we already saw that, okay, relation extraction, but you want to see from where, right? Is it for regular text, regular literature? Is it from tweets, from where? So I guess that's one question people can put in the chat their opinions, and they can raise their hands, but I need to figure out how to find the participant.
Yeah,
Please.
Cece, I can help monitor the chat. And Martin pointed out that in terms of types of tasks, entity normalization was missing. So we can add that. And if you want, I can make a couple comments about sources and applications. So for the first time, this BioCreative, we did social media mining, and it seemed that that was very successful. And actually, there was some social media on some of the interactive tracks too, especially the last one, topics. So if there are comments, you can either put them in chat. We've had internal discussions from time to time about using things like clinical health records, medical records, which is very challenging. And we heard Özlem Uzener talk about the challenges of some of that in her description of the adverse drug reaction challenge. But
so
yeah.
I see people are putting exactly what you just said, the clinical notes, but could be challenging. Also, someone is saying sources, literature, EHR, clinical notes, social media, patents by Raul.
I would add also clinical practice guidelines, which I think really require quite a lot of NLP, because people, medical doctors, for them it's difficult to follow these lengthy documents and to find information there. And then I think for some serious diseases like cancer, that there's some estimates that 30% of the times the clinician doesn't follow the practical guidelines, because it's very difficult actually to find what you're looking for in there. So I would suggest this, if you look for some novel document type, clinical practice guidelines are highly relevant for many kinds of applications. And we already had social media patterns and full text articles and abstracts in previous tracks.
Okay.
I will also add that the kind of sources also depend on the application. Even within given the broad spectrum of literature, and there are different types of articles published in the literature, and sometimes case report is important, sometimes systematic reviews is important. So depending on what we want to text mine and what's the application down the road, you may think about different types of articles within the broad sense of the literature.
Okay, so talking about applications, what would be applications of interest to this crowd? So
we had a whole panel on adverse drug reactions. And
yes,
be a lot of interest in that. So that's, but as discussed in the panel, that could involve a number of different kinds of sources, from social media to toxicology reports to the literature, clinical information. So it cuts across a lot of different sources.
Actually, it's a pretty hot, important topic now with COVID-19, with the vaccines. There are so many reports of adverse events that are sent by individuals. There are thousands and thousands of reports coming every day. Well, now they're going down, but it's something that they have to deal, the companies with. Sometimes they cannot just do it manually, so they use also algorithms to manage all this information. So it's useful.
Thank you, Raul. Okay, great.
Are those kind of reports public?
So that's the problem, right? So this ICC trying to make them public, so the anonymization factor, right, we're discussing. But I think that it could be possible, but we haven't done it in the past. But for example, let me give you a different example. Toxicology, we have this eTransafe project, European project, and we are making public toxicology reports, which is very unusual, but it's just a matter of anonymizing things and I think it's just a matter of exploring this.
So could you put the name or the link in the chat box for everyone or for that project that you just mentioned? Thank you. All right. Thank you. All right. So another question we have regarding the discussion here is about what are bottlenecks, because we do see in all these activities that there are all these methods that are developed in the shared task, or we do see some applications in the interactive task, but in the end, when someone wants to apply that into even a pipeline or just using the method, there's always some bottleneck in which there's this research team that the postdoc left, or there's no resource to maintain. So what we want to know is exactly what is your opinion in terms of what are the bottlenecks for preventing developments in this challenge activity to be sustainable, or the other way around. How do you envision that we can promote that to make the things that are developed under the biocreative to be sustainable? If anyone on the panel has any opinion, you can just.
I think the FAIR principles are a good starting point, because sometimes it's even difficult to find these tools or to know, you know, very basic things about them. So I think FAIR principles might be a good start. From our perspective, another like competition, we actually wanted to give prizes for people to make their tools accessible. But this requires that you need to have some minimal technical specification. What does this actually mean to get these things up and running in some way? How you specify this, how this system should be released? I think one contribution of biocreative could be to have some minimal technical specifications on how such systems might be, let's say, Dockerized or put into some container, or get these things up and running, at least at some common place or some like cloud platform or something. Because many of the teams might do it if they get a more clear technical specification and how they should release their system.
So I would like to hear from the teams, if there's anyone present here, to see how do they see if they are requested to follow certain specifications for having their system or the method Dockerized or something.
I would also add maybe open source, right? In terms of Docker, you can Dockerize, but if there could be some kind of requirement for open source release, that would be really nice. I think that's a challenge, because you read about all these papers, but then you don't know exactly how to implement them.
Okay. All right. I think I don't see. Here says open source for people to contribute, Emmanuel. Okay. Yes, that's very good.
One real challenge, though, it's not enough just to make them available. They have to be maintained, because there is bit rot. And maintaining these systems, if there's no clear use, is often very challenging.
Okay, and I guess we are almost getting at the end. I have a couple more. There are a couple more questions. Okay, someone is saying, Amy is saying, additional support guidance for developing documentation. That's awesome. That's a very good point. So that's.
I think there also needs to be some kind of incentives and for people to do that as well.
Yes, so I totally agree with Si Young. So if you ask something beyond what the competition or biocreative is doing, like evaluating the implementation side of systems, to document and actually make these tools available is quite a lot of hard work. And sometimes, especially in an academic environment, there's no clear, why should I do this? Or why should I put extra effort into that? And I think biocreative should, what one important thing would be, what would be the let's say, the incentive from our side in helping these systems to make the code available. Obviously, quality and you know that these systems are working very well is an incentive to actually get them being used, but also like visibility, help in the documentation, technical assistance in the specifications and how the systems can get up and running somewhere. Maintenance, I think what Lynette and sustainability, what Lynette mentioned, is very important. I'm a little pessimistic and what we could do there, but definitely it's a very important question which should be placed up front on at least have some sustainability plan of some of these systems, because if they see that these tools are being sustained somewhere, they might put the extra effort at least to do the technical, implementation documentation part. And
so yeah. Amy here is saying that building out a tool that is accessible is a lot of time and work. Many don't have funding or time to do this. Providing this type of documentation and possible maintenance support may help bring these tools to more people. So we agree.
And okay. I will just point out the obvious, which is all of this is related to uptake, actually getting people to use tools in their daily work. And this is a challenge that we have been wrestling with possibly since the beginning of BioCreative. And yeah, any ideas about how to facilitate that? I mean, this was one of the points of doing the various interactive tracks, is to figure out ways of encouraging uptake, but we still aren't there.
Yeah, this is Amy.
Yes, go ahead.
Sorry. I was just gonna add in at the CCTR where I work, like we support a lot of biomedical tools for research, and one of the problems that we find is the actual continued maintenance, like the funding and the personnel for that is difficult to get when you're funded through grants. They fund you for getting the tools up and running, but then getting funds to continue maintenance on the tool is difficult. So that's long-term funding and support for maintenance and keeping tools updated, I think, is probably one of the biggest bottlenecks to getting some of these tools out there and usable, because they might be maintained for a year or two, but it's just hard to continue that support without extra help. So
thank you, Amy. Any other
yeah, just one consideration. Yeah, that is true, and unfortunately I don't think a BioCreative can do much on the granting side, because I know this also. BioGrid, we struggle every 5 years for the NIH renewal, but kind of had a crazy idea that all the groups really appreciated the feedback from the users, and they would like to have multiple rounds. And I was thinking if we can just start to create some kind of a bigger effort where we start having not just few people which are volunteering, but a bigger body of people that we can build over time, and not just for one competition. And we can try to keep it there for a longer time, and these tools maybe can be evaluated. Otherwise, like this time was really, I think it was really tricky because we couldn't really match. So they wanted to have a lot of bench biologists, and I think we had only 2 into the group of users, and these are the most difficult ones to recruit, and these are the most and somehow more targeted by all these tools.
Yeah, and actually I made a lot of effort trying sending emails and contacting people that I like bench scientists, but no.
Yeah, because there is no incentive there.
Yeah, so we have to figure out a way and create a match.com for the systems and users. And,
well, probably some more institutional commitment, like PhD programs and things like that. So that you have rather negotiating with every single user, we can try to contact institutions at a higher level, and and that will be more, in my opinion, more effective.
Yeah, a key constituency may be the potential consumers on industry side. So biotech companies, pharmas, who is going to benefit from these applications if they were developed? And perhaps we could look into some kind of, I hate to use the term, public-private partnership, where potential consumers might get together to provide some of these incentives and some of the more sustained funding. I like the idea of a match.com too. That's good.
Well, we have to think about how to make best connections. I mean, to be honest, so far, because of especially in interactive tasks, because we've been doing biocuration, and I'm from the biocuration kind of membership, it has been easy to recruit members from that community. In order to get others, we have to find additional kind of channels of communications of key people that could be ambassadors for for getting recruiting the interesting parties, right, to try the methods.
Yeah, okay, I totally agree. And I think we've been successful, in fact, bringing the biocuration community with the text mining community, and in the future biocreative, we just need to branch out and think of other potential users. And there are, I assure you, there are potential users. Pharma is definitely one of them. I know that for sure.
It's also about the timing and everything. Like you have to have the time. Like, for example, one explanation I want to give to the participants in the interactive task, the developers, is in the previous biocreative, we did have a run with the users. So basically the user test the systems and the developers get the feedback, improve, and so on. So it's like more the user in the human in the loop in the development. Here we just expose whatever you have, but we can try to go ahead and try this exercise again once you have incorporated any of the feedback, or we can try to recruit more users, because we do have the tags there, and everything is open. People can do it, so you can even advertise in your own in the communities you think you have more impact. So we'll see. It's not an end. I think we can continue recruiting participants. Okay. Dorothy says agile processes. Dorothy from NLM. Okay. All right. I think we got to the end. Is there anything else? I just want to thank you and want to make sure we will have the recording of the workshop, so we will make it accessible to you on the website. And please don't hesitate to reach out for any question and any directions that you want us to move. Please send us your feedback. Thank you, all the panelists and speakers. And
thank you, Cece, for your great organizing of this. And also many thanks to Chris Martin for doing a great job actually running the virtual session. So thank you very much.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye.
Bye.
Bye.